Hey, Ron.
Hey everybody,
How's you?
I'm pretty well. How you guys doing?
Yeah, we are doing pretty good. Hey, Dimo. How's you?
Hey, I'm doing pretty well. Apologies for no camera on my end. My camera is a little broken. I have echo. Okay, I'll
That's
try and fix
okay.
it.
That's okay. We're gonna wait 1 more minute, and then we'll hop in.
Okay, I'll mute myself while I try to figure out the echo.
Yeah, sure.
Okay, thanks.
Okay, Ron. So I'm putting myself on mute and going off air. The stage is all yours. Enjoy.
Thank you very much. All right, so like the slide suggests, we're going to be doing a workshop on Scribble. And let me first give you a really brief introduction into me and Dimo, who will be giving this workshop to you. So I'm Johan, and I am a security researcher, product lead at Consensus Diligence, working on things like Mythics and Scribble, for example, to make smart contracts more secure. Dino also works at Diligence, and he's the mastermind behind Scribble. He's the main developer. So if there's any really in-depth questions that you have, he'll definitely be able to answer them. I'm going to be going through the main track of this presentation, talking about Scribble, talking about the examples in the workshop, and then Dimo's going to be managing the chat to answer all those difficult questions. All right, so like I said, we're going to be doing a Scribble workshop. And the structure of it is roughly as follows. I'll first give a brief introduction about Scribble, property checking, and that's just to give you the context that we need to go into the exercises. Then there's two main exercises that we'll definitely do, and depending on how long that takes, how long we're busy with answering questions, we'll have time for a third exercise, but we'll see. And then we're going to end with a small wrap up. Okay, so before we dive into Scribble, we need to start with properties. What are properties? We need to dive into properties because Scribble allows you to work with properties. So what is a property? Well, properties are logical statements that you expect to be true. For example, some cars are red, or there's some red in this slide right now. Another example is, which might be more familiar to you guys, is a function example only returns positive numbers. And the key here is that these properties describe statements that you expect to be true. So they might not actually be true. They are essentially assumptions that you have about a smart contract. And if those assumptions aren't valid, then that's usually a big problem, and vulnerabilities arise from that. So what do? You test or verify them. And that's exactly where Scribble comes into play. Scribble is actually two things. So first, it's a specification language for writing down properties, and then it's a runtime verification tool to actually work with the properties. So it's a specification language, which means that it is a language that you can use to write properties in. We've closely based it on Solidity, and you use annotations and you write your properties down as annotations. I have a little example here of a property that says that the function "this cannot be hacked" always returns a positive number. It has three parts. The if succeeds, which describes what kind of property it is, and in this case an if succeeds, so a property that must hold if the function executes successfully. Then there's a message, which is optional, which our tools use to report findings if they find a violation of your property. This is really useful if you have a ton of properties, because it will make it easier to find which ones are actually violated. And then there's a third part where we have the actual meat of the property. So here, result is compared to 0, checking that the result is positive, which is actually what's being checked. The second part of Scribble is that it's a runtime verification tool. So what's that mean? Well, it takes the properties that you've written and instruments them into the code. So it will inject Solidity code that actually checks those assertions that you have and raises assertion failed events if they don't hold. What's nice about this is that because we essentially encode the properties as pure Solidity, we get to use existing tools that do fuzzing and symbolic execution and use them to find violations. This is an example of what this instrumentation looks like. On the left, you see the original example, and on the right, you see how we added an assert statement at the end of the function, saying that the result must be bigger than 0, essentially encoding the property. Now, this is a very simple example, but it does highlight the rough structure of what an instrumentation actually does. All right, so that's all for the introductory part. Now we need to do a little bit of setup before we can actually do the exercises in our workshop. So we need to install a few different tools, and I think one of the announcements already asked you guys to install some of them. So that should speed things along. But we're definitely going to need Scribble. Also, you can also install Truffle or use Truffle for this workshop, but it is not strictly necessary. And then we're also going to use Mithril and MythX. We're going to use these two tools to automatically find violations for the properties that we're going to write in this example, to show you how you can actually make use of the properties you write with Scribble. All right, so this is all you need to do to set up all the tools. So it would be, let me type them in the chat as well, so that you can just copy paste, because copy pasting from slides is very difficult. And then we'll continue to the next one. I think I might need to go to the YouTube stream to actually write these down. Timo, do you think you could put these in the chat and then I'll continue to the next slide?
Yeah, go for it. I'll figure it out.
Cool, thanks. Okay, so here are some useful links that you can use after this workshop to dive deeper into Scribble, or maybe contribute to Scribble, or use the MythX platform. So the first link that you'll see here is pointing to docs.scribble.code, which is where our Scribble documentation lives. So anything that you need to know about running the instrumentation, running the Scribble CLI is there, but also everything you need to know about the specification language aspect of Scribble is there. There's a bunch of examples, so it should get you started pretty quickly. The second one is pretty simple. That's the repo where Scribble lives. So if you're interested in checking out the code, maybe contributing, go there. And the final link is MythX, which is the platform that I called out before. MythX uses a range of different analysis techniques to find the violations for the properties. And it's going to be a little bit more powerful than Mithril. All right. So the first exercise in this workshop is going to be about finding a bug in an ERC20 contract. I've set up a truffle bugs and Git repo, so whichever means of pulling you prefer, you can use that, with everything that we need for this example. There's a README in there that describes all the steps of the workshop. So if you need to catch up or miss a step or want to redo the workshop, you can find everything you need there, and even more. So these are the commands that I used to get this exercise on my machine. It's also possible to just do a git clone. All right. So now let me actually share the screen I have with the code. Things around, share screen. Yep. All right, so I'm not sure how to actually make the screen appear now. Yes, awesome, thank you. Okay, so what we have here is a simple ERC20 contract, but it's slightly off, and we'll go into that pretty quickly. But it's a simple ERC20 contract. There's all the functions that you would expect: total, supply, transfer, approve, and in this case, there's something odd in the transfer function. Normally, what you'd see is that you first update the from balance, so the balance of the message sender, and then the to balance, so the balance of the recipient. But here it's kind of split up into 4 steps, where we first compute the balance minus the balance of the sender minus the value, and then the balance of the receiver plus the value, and then we set these changes. And there's something weird going on there, which will allow an attacker to actually gain some tokens in this contract, and we can find that by writing a few properties. So let's go ahead and do that. In this case, we're talking about, or I want to specify something about a function and I want to specify something about what needs to happen if it executes successfully. So I'm gonna need this if succeeds kind of specification. Also write a message so that later on, if mithru or mithx finds violation, I can actually easily see which property is violated. So let's see. Oh yeah, let me increase the font size a little bit, which should make it easier to see. Maybe this is a little bit too big. Yeah. Okay. So the recipient should get value added to its balance, which is obvious, right? Because if the transfer succeeds, the recipient should get money. So the balance 2 it must be equal to something plus the value that we send. Oh, what we actually want to say is that the balance after the function is equal to the balance before the function plus a value, So this is where we can use the old keyword that's in Scribble, which allows us to refer to the value of variables and expressions at the beginning of the of a function instead of just at the end. Right. So what this function, what this property now says is that the balance of 2 after the transaction is equal to the balance of 2 before the transaction plus the value. Now, there is one case, and that's a really relevant case, in which this is actually not valid. And that's a case where you I'm going to zoom in a little bit more. And that's a case where you send money to yourself. That's actually shouldn't happen too often, because why would you send money to yourself? But it is a case where no value should be transferred at all. So we're going to say that the message sender is not equal to the recipient. And only in the case that that's true, will we check this. So that's all nice, and this will verify just fine because it's valid. Now, this case that we just described where you send money to yourself, let's look a little bit more into that. Because if you send money to yourself, then nothing should change. In short, sending money to yourself shouldn't change the balance. So let's say like message sender is equal to the recipient, in which case the balance of the recipient is equal to the previous balance of the recipient. Yep. We can even generalize this a little bit more, because what we can say is that in general, the sum of the both balances needs to stay the same. So if I send some tokens, X tokens to someone else, then my balance plus the other person's balance before and after the transaction should be the same, because we aren't magically creating tokens. That's called the property no magic tokens. All right, so this is gonna be old yeah, we need to use the right variable names. This is the same as if we before and after. And you might have noticed that these last two properties will catch the bug in this smart contract. But let's have Mithril actually find the bug. So the first step, once you've written a few properties that you want to check, is to actually do this instrumentation phase. This is where you'll need to run a scribble command. So the command is as follows: scribble arm-n files, and then the file that we want to instrument. There's actually many different things that you can do with Scribble and many different options. And we're just going to use this one for now. If you're interested in all the capabilities of Scribble, please check out the documentation because there's a lot of useful information there. But what this command will do is it will take the annotated contract and do that instrumentation and replace it with the instrument version. So we'll be able to see that. If I didn't make any typos in my properties, but I did. So what you'll see now, or what you see now in the terminal output, is that I made a mistake in using the variable name balance instead of balances. So it gives you some nice debug information telling you that balance doesn't exist. I made this mistake a few times. So balances. Okay, should be correct now. All right. So it's kind of managing the different contracts in there and making sure that everything is in place. So this is what you're actually seeing now is what Scribble creates. It's this instrumented version of the contract with the properties as assertions and assertion failed events. Downstream tools can look for these and find violations, and that's our next step. Because now I'm going to run Mithril on this smart contract to see if it can automatically break the contract, find a violation for one of these projects. So I actually made a script with the Mithril command that I'm going to use, which is in the screen right now. So let me start it because it might take a second or two. So the first word, myth, is to invoke the Mithril CLI. The second word says that we'll be analyzing a smart contract. Then this points it to the now instrumented smart contract. The -T tells Mithril to only look for one transaction deep, which is totally fine in this case because the vulnerability should be coverable within one transaction. And then this final bit tells Mithril to only take 60 seconds. So in this case, we have a pretty small smart contract, just an ERC20 token, and Mithril can cover everything just fine within that minute. But in other cases, you might want to give it some more time, give it a higher transaction depth so that it can actually appropriately cover the elements of your contract. And in the output here, we see that we found a violation, namely that sending yourself money shouldn't change your balance. This is the first property, and there's something really interesting happening here, which is that we don't see a violation for the last property. That's because by default, Scribble will insert both an assertion failed event and an actual assertion. What's interesting is in this case is that if property 1 is violated, then property 2 will also be violated. But because of the assert, we never even reach this, so it's not reported. I'm not super certain about the actual tag that you can use to remove these assertions, but Demo will probably be able to put that in the chat. In any case, we found that there is a vulnerability now because we know that sending yourself money will change your balance. In this case, for the better, so an attacker would actually want to exploit it, which is nice for them, but not so nice for the developers. Now that we found the vulnerability, we obviously don't want to keep this annotated source code. Instead, instrumented. Instead, we want to return to the original annotated source code. So what we can do is really easily, we take this command that we used to arm the contract and we make it disarm. Running that will return us to the original state where we have our nice readable ERC20 contract and our nice properties. And now we know that this property is being violated, so we need to switch some things around in the code to make it work correctly. All right, that is exercise number 1, where we can essentially use a few if succeed statements to easily or find this problem. Now let's go on to exercise 2. So this is in the exact same location or a similar URL as the first Scribble exercise. Let me edit on the screen. So you can just do a git clone. Let's see if I can share the link real easily. In any case, you can go to this URL or just clone it. It's just https github.com consensus and then Scribble exercise 2, which we can clone. I already have it here. So let me just move over to that directory. And in this repository, we have the same situation. There is, again, a README that gives us all the information that we need to follow along for the exercise or redo the exercise after the workshop. And there's another contracts directory. So here you'll find a vulnerable ERC721 contract, which I've copied to a working sample so that I can make changes without modifying the original one. You don't have to do that. So this is, again, just a plain ERC721 smart contract. This is, I believe, taken from the Open Zeppelin implementations, and we made some small adaptations to make it easier to work with this contract in a workshop environment, but nothing really major has been changed. More specifically, what we changed is we made a function public that used to mint new tokens, which the internal fuzzer behind Mythex will use to create a state which is exploitable. Without that, the fuzzer will never be able to reach an exploitable state. So that's why it's in there. All right, so let me go straight to the code that I want to annotate for this exercise, which is the transfer function. No, it's a transfer from. One of the most commonly used properties in ERC721s, but also other tokens, is the fact that you don't want people to be able to send funds or specific tokens to the 0 address, because that effectively deletes them, and you might not want to support that. So we can easily write a property to check that that never happens. We'll use another it succeeds, and let's say never sends to 0. Now it's also pretty easy to encode that as a condition, because we'll say that 2 is not equal to address 0. Now, in this case, you can see that the check is not there, and in a minute I'll run a scan to actually have automatically show that this property is violated. But let me quickly write up a few more properties that are relevant for this transfer from function. So we want to make sure that if we transfer funds to someone, or if we transfer a token to someone, that they actually are the owner of the token after the function succeeds. So to see token. So there's a function in ERC721 called owner of, which gives us the owner of a token if we pass it the token ID. The transfer from will send the token with token ID from address from to address to. So we want to check that if the sender actually receives the token, then after this function, the owner of token ID must be equal to the to address. The other part that we might want to check is that the sender or the from address was actually the owner before the transaction. Then we'll use another keyword old function call here again in a minute. But let me quickly try out a message. The sender actually has to. I mean, this is pretty important, right? Because otherwise we're able to not take tokens from anyone. So previously, in the state before, the owner of token ID must be equal to from. Now there's one more thing, because this is a transfer from function where it's not only the actual owner of the token that can transfer the token, it's also people that are authorized to send that token that can call this function. So the sender is authorized. So in this case, we want to know whether the owner of the token before the transaction is the sender or whether they have authorized the sender. Because we're going to essentially write a very kind of complex statement here with various clauses, we're going to use a let statement to essentially create an intermediary variable. So I want to store or bind actually the old owner to this variable called old owner. Now I can write a condition pretty concisely that uses this variable. So the condition that I want to check here is first that either the sender is the owner or the old owner, or the sender is approved for this token, which we can use the get approved function for. Ah, nice, it already auto-completes for me. So we want to see that the message sender is equal to the get approved of this token. There is one more case where you can approve someone, which is if you approve someone for all your tokens. So let me quickly write that one out. That's a little bit longer. Okay, so essentially this function will return whether the message sender is approved for all the tokens held by the old owner. All right, so I actually have ran a scan on this contract before with Mythax, and I'm gonna redo that scan on that particular contract with the message names that I used there, because Mythax is able to cache analysis results. And by doing that, I kind of speed up the results that we're able to get in this presentation. So this is the original contract that I talked about. And let's see, yeah, the same properties are here as well. And now what I can do is from my shell, I can run this command to analyze the smart contract with Mythax. So in this case, the Mythax CLI utility will be used, and it will automatically interact with Scribble for us and do everything that we need for the instrumentation, and then submit it to the Mythax CLI, Mythax platform for CI. Let me quickly post this here so it can be reposted. Yeah. All right. So Demo will post this command in the chat so that you can copy paste it. The same command should be in the README as well. So even if you miss out on the chat, you can look back there and see what you need to execute. But really simple. This command, the first word is invoking the Mythax CLI. The second option is the output format. It's simple, which means that we'll get a nice output in the CLI that we can read. We'll analyze again. We'll use the standard mode, which means I think it will run for about 15 minutes and do fuzzing, symbolic execution, and static analysis to find violations. It will look for violations in this smart contract, the vulnerable ERC721 with the properties that we wrote. We have this option called check properties. This will make Mythax run in property checking mode, so you will not get all those generic findings, or I shouldn't say generic, but Mythax is a platform that also can find vulnerabilities that are not specifically related to any of the properties you wrote, and enabling this mode will make it so that those aren't reported, so that we just get the information we need on violated properties. The Scribble tag tells the Mythax CLI to look for annotations and do the instrumentation. And finally, we set the Sol C version so that it knows how to compile the smart contract. So let's run that. It will first take a bit to do the instrumentation, and then it will tell me that it has a job to submit. And for me, it should return within a second. If you do the analysis yourself, and maybe if I'll have time, I'll run it on my working example too, then it might take up to 15 minutes, and it will do a lot of analysis in that time. But you should be getting the same results. So here we see, again, 2 violations, 1 assertion failed event and 1 assert. And remember, this is because Scribble inserts 2 assertions by default, 1 assertion failed event and 1 assert false. That's for compatibility with other tools, because most tools are able to look for plain solidity assertions. But we see here that the property can delete by sending to 0x0 is being violated. And let me quickly hop over to the Mythex dashboard and hope that the stream will allow me to do that, to show you the actual dashboard results, because there's some useful information in there. All right, so this is the report that you'll see for this analysis if you go to the Mythex dashboard, or at least this is what I'll see. So there's a little bit of non-determinism, so the coverage graph might be slightly different for you. But you see here the two findings again, the two assertion fields. Yeah, I should increase the font size here too. This should be better. Okay, so we have the two findings here, but we know about those two already. There's also a coverage graph here. So Mythex uses fuzzing and symbolic execution in the backend, and those iteratively explore the different paths through a smart contract, which means that, like a test suite, they will cover more and more over time. And you see here how that coverage progresses and how it is able to cover more and more the more time it has to drill down into a smart contract. Now we can look into the instrumented file that was actually analyzed. And we see here on the left, we see green bars, and these indicate the very same coverage. These show us where the fuzzing and symbolic execution were able to reach. And if we go down a little bit into the actual ERC 721 code, then we see that most of it was covered in this 15 minutes. If you have a very complex smart contract, you might need to use the Mythex deep mode, which gives you, I think, 45 minutes of scan time. All right, but let me scroll down to the actual transfer from. And here we see the finding where there was a violation of the property can delete by sending to 0x0. And what's nice here is that Mythex can show you the actual trace that we found internally to violate the property. So here you see that the attacker minted a token and gave it to themselves, I think, and then sent it, which sends to the 0 address. And that is exactly what our property doesn't want and what would trigger a violation. So now what you could do technically is write a truffle test or hard hat test or whatever framework you prefer, and write these calls, and you should have the same violation. You can write a fix for the bug and then rerun this test or trace to see whether you actually fix the vulnerability, which I think is very useful. Okay. Let me move back to my editor again. Yes. All right. Can you? Nice. Thanks. Okay. So there is a few more interesting things that we can do with Scribble. So I prepared a few examples where we can just highlight or easily highlight different capabilities of the Scribble language. I won't show you how to actually use Mithril or MythX to find violations of the properties here, because I don't think, or we didn't inject actual vulnerabilities here, so they should be correct. But yeah, let's just go. So I'm pretty sure that if you're familiar with smart contracts or Ethereum smart contracts, then you'll have definitely seen the use of the ownable pattern. The gist of it is there is one address stored in a smart contract, which is the owner, and there is privileged functions that only the owner can call. And these functions are protected by the modifier only owner, which ensures that this is the case. Now, one thing that we can state about this in a so-called invariant is that we want to say that only the owner can actually change who the owner is, because we don't want just anyone to be able to override ownership. So let me write that down. We'll use an invariant, which means that it should always be valid for every transaction. Owner can... Okay. So what we want to say is that if the owner changes, or what we can say is that if the owner changes, then for sure the sender during that time must have been the old owner. So let me write that down real quick. The old owner is not the new owner, means that the old owner plus message sender. Okay. Now, this is actually not a valid property because ownership is a little bit more complex. Because during the constructor, we do change the owner from 0 to the sender of the transaction, as you'll see here, without the sender actually being the owner before. But the constructor is special because it can only happen once for a contract. So we'll say that if the owner is address 0, okay. So if the owner is not address 0, so if there is an actual owner set, which will always be the case, or should be the case after the constructor has set, has executed, and the owner changes, then we want to make sure that the old owner is actually the message sender. Now, there is another edge case in here because, oh no, I'm mistaken. So this will actually make sure that regardless of the code or arguments or functions that are in this entire contract or any contract that inherited, will always check or be sure that if the owner is changed from a non-zero address to another address, then the person doing that was the owner, which is nice because that's like the entire ownership pattern. All right, so we have 12 more minutes. Nice. Okay, so the other example I have is essentially just the very same as the one we started out with, but I just want to go ahead and fully annotate this ERC20 contract and show you how quick it actually is to take a contract like this and fully annotate it. Now, obviously, for more complex smart contracts, you need to think a lot more about the actual vulnerabilities that are in there, the actual properties that are valid for that contract. So it might take a little bit longer there. But in this case, we have a simple ERC20, so we should be ready. Let's just go from the transfer function into the approve function. So the approve function, what it does is it will set an allowance so that some person, so the person calling the approve function allows another person or address to spend some amount of tokens, which is signified with a value argument. And it's the allowances mapping in this case that actually stores like this allowance. So what we want to check is that after the approve function succeeds, that the allowance of the spender for the owner is set equal to value. And this is a pretty straightforward property in this case, yes, but that's also because it's pretty simple code. So let me write this down real quick. Spender has we could copy paste, but I'm not going to do that. All right. So that's it. This function doesn't do anything else, so we can continue on from here. The next function is a transfer from function, and this is actually does pretty much the same as the transfer function, but it allows people to use their allowance to send tokens for somebody else. This means that we can take the properties that we wrote for the transfer function and just adapt them a little bit to match up with the parameters that are used in this transfer function. So instead of using the message sender, we use the from address. So this code the transfer from function essentially is doing the exact same thing. We just need to replace things. So we can replace this with from. So from is not to, then to should receive the value. That's still true. Let's change this again. Sending to yourself or to someone self doesn't change the balance. Is also the same. Yep, that's still valid. Now we can adapt this from and to. All right, that's it. Now there are some more things that we can do because we want to maybe say that the allowance of the center of the transaction actually decreases with value if it succeeds. So allowance decreases with value. So the allowance of the sender is equal to the old allowance of the sender, but minus the value. We might also add another property saying that the sender should get value removed. We actually forgot to add that to the previous transfer function because we didn't really need it. In this case, we're talking about the and it's subtracted, not added. So that's it. That kind of specifies most of what we need, I think. That's actually something interesting to say before we wrap up. You can write a lot of properties and we can automatically check them. And maybe in the future, or probably, we'll write backends for Scribble that integrate with formal verification engines. And you can write a lot of properties, but the thing is that even though you might show that various properties aren't violated, you cannot show that properties you haven't written yet aren't violated. So essentially, if you don't write the property, you can't check it. Let me move into the presentation so I can summarize all that we talked about. But the application is breaking for me. Okay. Yes. All right. So thanks. All right. In summary, we looked at a lot, even more than I had expected initially. We have function specifications using if succeeds, where you can talk about what a function is supposed to do if it succeeds. We have used the old keyword to both specify how a function changes state, but also to essentially write a precondition for an invariant to check that only owners can change the owner variable of an ownable contract. This is called implication. So that was the arrow with the two equal signs in there, where it's like logical implications, which essentially is a precondition, or kind of a precondition how we used it. We also used Mithril and MithX to automatically find violations of vulnerabilities, but also to see how the fuzzer and symbolic executor were actually able to violate a property, which you might use to write tests or automatically exploit smart contracts. But there is more. Keep an eye on the documentation and the GitHub repo, because there is a ton of work going into Scribble. There are some new language features dropping soon. And like I said, we're working on that integration with verification backends to bring more capabilities to you. Yeah, make sure to follow us on all the socials and keep up to date. With that, I'd like to thank you all for hanging out and following along. You can find us on Twitter there. And we also have a website with a blog where we release a lot of blog posts, and some of them are about Scribble. So if you're interested in security in general, or smart contract security in general, it's a really good place. But also if you're interested in Scribble, that's where we'll publish our main updates. And that's it. Stop screen sharing and move over to the chat to see if there are any questions.
Hey, Doran, can you hear me?
Yeah.
Yep. So it was a very great session from both of you. Hey, Demo, you are here with me, right?
Yep. Yep. I'm here.
Yep. So it was a very awesome session from you all. We learned a lot about Scribble and properties. I got some responses from developers. They will be following the workshop after it will be recorded, and I've shared the Mythex promo code as well. So, yep.
Cool.
Thanks for that as well. So people can follow along. So, any question? We still have 1 or 2 minutes. We can take up
And
questions if there are any.
both me and Demo are on the Discord as well. So if there are
Mhm.
questions after, you can ping us there.
Okay. Yep. I will share the link. Share your profiles for the Discord and Twitter as well,
Cool.
so they
Thanks.
can catch up with you. So all good. Any point that you want to add for the ending session?
Nope.
Timo, it's all good.
Nope. That's all good. Joran had everything covered.
Yeah. Thanks
So
for having us.
yeah, and thank you all for being with us, our speaker for the Unchained Blockchain Security Conference. It was a nice pleasure meeting you all and having you with us. So there's a comment saying this was long but interesting stream.
Thanks. All right.
All right. So see you, Joran. See you, Dimu. We'll see you on the next event. Bye bye.
Thank you for your time.
Hello.
Hey Deepak, can you hear me?
Yeah, I can hear you. How are you?
Yeah, I'm all good. How's you?
Doing well, doing well. Where are you joining from?
I'm from India right now. It's about 11:15. What's the time there?
It's 12:45, and I'm
12:45. Oh,
joining from Canada in Toronto.
okay, it's pretty late, right? I can understand. But thank you so much for joining us, and we are pretty excited for you and for your session. So you can turn your screen. You can turn your screen share.
Sure.
I'll be switching out the layout.
Screen share. I'll share. So I have to share the whole screen. Give me 1 second here. Just move this here. All right. Let me know if you see my screen.
Yeah. Give me a second. Okay, so it's on. So I'm putting myself off air and on mute. So the stage is all yours, Deepak, and we are pretty excited for it. So
Yeah. Thank you. All right. Let me full screen this here. All right. Wonderful. Thank you. So I'm looking here because my chat window is here. So I'm just trying to figure out here. All right, give me just a minute here. Okay, so let me ask a question. Like, so I know like there are just a few people, so I want to keep it a little more informal and see if I can adjust the talk based on where everybody's at. I know it's late in India. Here in Toronto, it's like almost like 1 in the afternoon, so it's not that late. So I want to make sure that I don't put you guys to sleep or anything. So just yeah, it is winter, but today it's been bright, so that's why my room is bright. Usually it gets pretty dark here, and I have like this special light here that I usually use to use if there's not enough light. But today I have enough light in the room, so it's good. So just to get an idea, I know there are like about 4 people or 5 people on the call here. Just to get a idea, uh, like type in this message here where you're joining from, and also are you a builder? Are you building something, or are you more like a security professional, or are you just a crypto user? Like, just type in the chat. I'll just give a few minutes just to, I want to know, like, who's joining and what you guys are interested in. Wonderful. Security researcher. Pittsburgh software engineer, tech educator. Wonderful. Okay, beginner. All right. Developer. Any so are you guys also using crypto? Are you interacting with the different smart contracts? Are you working on Ethereum or any other cryptocurrency platforms? All right, wonderful. So penetration tester, cool. Yeah, okay. This gives me a good idea of like how I can tailor my talk, and also feel free to like message on the chat. So we'll keep it a little more interactive, because the talk I'm doing it's more of a survey, ETH, EOS, BTC, mostly research. All right, cool. Quantum at times. Wonderful. So what I want to do today is that just give us overall, what is it called, a survey of how people should be thinking about security in a Web3 world. So I've titled it for like developers, node operators, and crypto users. So we'll cater the talk based on like some of the things I just mentioned. So all right, so we have, okay, all right, so now let me, yeah, so as I said, like it'll be a survey. We'll talk about like, quickly about how to think about threat modeling, what are the different types of security practices one can use, and also focused on like how we should think about software security, how we should think about the infrastructure point of view, and also from operations point of view. So before we get started, I will just give a quick about me. I'm the founder of a boutique software consulting company called Multisig. And I'm right now helping C Labs, the company that is behind the Celo blockchain. So C Labs is building out the Celo blockchain, and I'm helping them build their own security team. And I'm also a community grants steward for the Celo blockchain. So we have access to, depending on the day and the price, access to between $2 to $3 million worth of funding that I can give for people who want to build on Celo. So if you have any project that you would want to build on Celo, or you want to do some security research, please do reach out to me. Happy to hear what you would like to do, and happy to fund you. And I want to give a few words about Celo and why you might want to consider. So it is a fork of Ethereum, but it's its own blockchain, the first like proof of stake blockchain. And also we are like the first like mobile first blockchain where you can literally create a wallet that is associated with your actual phone number. And if anybody, we have a small number of people here, so if you guys just ping me on Twitter, I can send you like $10 worth of CUSD, and you can see how it works and play. So I can literally just send it to your phone numbers and you can get it. So anyway, so if you are interested in building out on Celo, feel free to reach out to me. Just a quick about my background. I have done 12 years in more than 12 years in infosec, at least 12 in the industry, doing pen testing, incident response, more focused on like security program development and building out teams these days. As a hobby, I like to travel a lot. I spent 8 months in the Amazon of Peru and Ecuador. I also teach yoga, and I love to learn languages as well. If you're in India, like I speak about maybe like 4 Indian languages. Hindi thoda baat kar leta hu. Kannada is my mother tongue. Telugu koncham vastundi. Marathi, thodi Marathi bolto. Apart from that, foreign languages, Spanish, un poquito, español hablo, después, let me see, Italian, un po' di italiano, parlo anch'io. Anyways, so, and I have my Twitter here, so feel free to reach out. Also, like I like to think about security as a life skill, and I like to use it everywhere, right? Like you and me, just as an example, right? Talking about like these languages that I've spoken about, it helps you connect with the person that you're talking to. Maybe you're doing social engineering, or maybe you're doing some sales. So it's good to like, I think about security everywhere and how you can use that to like, hack, like, ethical hacking into people's mind as well, to get this kind of relationship when you're online, or even, when you meet people for the first time. It's good to build this kind of connection to get good at what you do. All right, so as I said, we will be doing a survey of the landscape of security in general for Web3. I'll talk about like high level, all the different parts. So if you have a pen and paper and you want to take notes, all you need to do is just write down like anything that I talk about is interesting from whatever project you're working on, or any research you're doing. That way you can go deeper into one of them. So I will not be going deeper into any one topic, but in the text, I'm seeing the text here as you type. If you have questions in between and you want to dig deeper, we can go in them. And again, like a lot of people ask me, like, what is relevant to me, right? If there's like too much insecurity, like what is relevant to you based on your stage of the project, and the type of project you're doing. Again, I want to do caveat. Everything I'm talking about here, I have personal, professional experience doing it. That is like somebody has actually paid me money to do it. It's not like a hobby. One part where I am not that experienced is around smart contract security, and I think the last talk was talking about smart contract security and some scanning. So that is that. And whatever I talk about smart contract security, take that with a grain of salt, because I actually haven't done much of it. All right, so threat modeling, right? So I'll just spend like, 2 minutes talking threat modeling. This doesn't have to be like a formal threat modeling you spend like 6 months doing and writing, getting all the documents. You can just do a basic, any project you're doing, anything you're working on. It could be a small smart contract security, or just your personal operational security of how you manage your keys, right? So I think a basic threat model, just spending like about 1 to 2 hours workshopping just with yourself or with a team is always helpful. So I like to break threat modeling in a very, like, use this template in a high level, right? You identify, enumerate, and take action, right? So what are we doing? Like, before you do anything, right? What are we building, or what are we trying to use? What are the different components of these tools that you're using, and what are the different interactions? So this is the identify phase. So I'll just give an example here. Think about a application. Let's say this is like a DApp on your mobile. Like, let's assume that it's a application on your mobile phone that connects, that allows you to send money from person A to person B. So the app itself is one component of it. The user is another component, and then the app connects to the internet. So there is a channel there between the app and the internet. And then using the internet, you connect to either the app server or a blockchain. That is one component. And then on the other side, when you send some money, there is another user who's actually getting that money, and that person also has this app or a DApp that connects back to the blockchain or the app server. So once you break it down, right, like break all the pieces down, all the important pieces, and then you want to enumerate, right? Like, you want to enumerate of all the things that can go wrong, right? In this case, in our example, like, we have these few components. The device itself can get hacked that the user A is using. The app, the communication between the user and the app server or the blockchain can get compromised. So that is another threat. And what is the other one? Like, maybe the user A themselves are not trustworthy, right? They may say, hey, I sent money to you, but they didn't actually send the money, right? So these are some things that you will enumerate. And action, right? Like, once you enumerated this, what are some actions you can take that will allow you to prevent some of these threats, right? You might actually create like a millions of these threats, right? Like, how do we prioritize, right? Then you would like to make a priority and say, hey, these are some things that I know about and I will fix it. And there could be other things that you know about, but you won't fix it. But actually knowing that you have this issue will really help you in the long run, because you know that you took this uh, decided to accept a particular risk, right? In this case, maybe there are some examples that you could do is, maybe you have like an antivirus on the app that you ask people to run to make sure it's safe. Maybe to protect the channel, you'll use HTTPS. To protect the app, you could use like certificate pinning. And of course, if to make sure that the user is honest, you'll just check for the transaction on an explorer. So I've given a very like simplistic form of threat modeling here, but I would like recommend people to do this, even if it takes like half an hour. Just take half an hour and do it. so that you know where you stand. You have a map. All right. Moving on. So what are the different types of security practices? Then I'd like to call them controls, audits, and testing. Let's talk a little in detail. What are controls, right? So you created your threat model. You said, I want to fix this, this, and this. So take those actions and create into actual controls that you can configure on your engineering setup or your software development setup, whatever that is, right? For example, one action could be, oh, we want to make sure that we're using multi-factor authentication, right? You could use like a hardware wallet like YubiKey, or you could use Google Authenticator. So these are controls, right? These are actual controls that you will set up either in your software or the configuration of the software or your infrastructure. And then you have audits, right? Like, so you did all these controls. How do you know that these controls are actually in place? Then you can have somebody go and create a checklist and say, hey, I said that I wanted to fix, have two-factor authentication. Is that actually enabled? So somebody would go and do the audit of that. So this is basically just like a checklist-based system. And then the other part is testing, right? Okay, like I did all these things, and I said I did it. Like now, how do I know that it actually is in effect? So this is where your testing will come. So again, like the cost will change in terms of resources and price based on uh, where what you want to do. And I'll go a little faster here because I know a lot of people are already in security here. The other thing to think about is, are you looking to do these kind of assessments from the internal perspective or the external perspective? For example, like, are you looking for threats, like insider threats or outsider threats? So using this point of view, you can have like some testing done internally, from an internal perspective and externally. And who is actually doing this test, right? Are you doing it yourself, or is a third party doing it? And the third aspect to this is it automated or manual, right? If you can get a lot of low hanging fruit covered if you do automated testing, for example, from the last talk, or you could like actually do a manual test. All right, so who and what, like who should be doing these tests, right? If you are looking at the controls, that definitely should be done by your team or yourself, if you're one person, uh, and whether it is being done on the internal side within your company or outside. So this will be done internally. And how is it done? Most of the time it's manually done. You have to go and configure all these things manually, but you can automate it sometimes using things like Terraform, Puppet, and things like that. You can automate some of these controls as well. Next is the audits. Like, who does the audits? So usually the audit should be done by a third party, but if you're a small team, you can do it internally, preferably by a separate team. That way there is no overlap and conflict. Is it being done internally or externally? So audits are usually done internally within the company. They have access to your own internal systems. Will it be done in an automated way or manual? This can be done both. Now going down to testing. So this is usually a third party who does it, or a separate team. And this can be done both from an internal and external perspective. Internally, to find out internal weaknesses within your application, and externally from the internet, right? Again, this can be done both automated and manual way. Okay, so what should you actually be doing? It depends. If you're in the early stage, it's best to just set up some security controls and do self audits. But because we are in crypto, there might be some regulatory requirements. If you are like deploying some smart contract, doing some things like with related to, I don't know, like with securities, then you may have to do like third party audits. Maybe there is a vendor who you are supporting. They may need like some certification requirements that might only be done by a third party. And of course, like if you are touching these like high value assets, then it's better to get audits done by a third party. Cool. So let me pause here and see. It's all basic. If anybody has any questions, I don't see there are any questions. But as I said, like security and going into technical stuff can get a little what is it called boring. So I wanted to stop here and tell a small story that'll actually help you think about security and also the interconnectedness and the composability that we see in the Ethereum ecosystem and the other blockchains as well. I was living in New York back a few years ago, and I was hired to do a physical pen test of a financial institute within New York. So what happened was this was a financial institute, and they wanted me to make sure that I actually done a test, and nobody had gotten into their company, and they were like so confident, like they're like, there's no way you can break in to this financial institute. So the first time I went there to just do like some scoping and to do some recon kind of work, I was actually able to tailgate into the entire company the first day. And then when I came back and to the call and told my client that I was able to get in, the guy wouldn't believe it. He was like so pissed off. He said that, I got lucky, and he was like, this is a lucky thing, so this is not really applicable. I decided to go back again, and this time I said that I will actually interact with people and do it. So if you don't know New York, New York has these huge buildings with like the most mean looking security guards in the front desk. So what I did was I called them up, I spoofed my number, and I said, hey, I'm calling from the office, please add this electrical engineer on the guest list. And because the number showed up as though I was calling from within this company, the front desk people said, yeah, sure. And I just gave my own name. And then they put my name in the registry, and I showed up actually on a Friday evening at 5 p.m. and everybody is leaving for their weekend. So I show up there. The guy gives me like a guest pass, and he says, okay. And then he opens like the turnstile. He lets me in. So this building has different companies. So this financial institute had like one whole floor, and to enter there was this door, and then there was like this waiting area, and then there was a bulletproof glass where their own special security guard was like sitting behind there, and next to him was this like man trap, right? You have to scan your eyes, and you have to have your badge to get into this man trap and then get into the company. So I show up with this like random looking bag. I don't even know if electrical engineers use this kind of bag. There's a clipboard there, which is always helpful. Wore like these like toned jeans, wore a baseball hat. I don't know if they look like this, but this is my typical idea of how electrical engineers would look. So I show up there, go upstairs, and I don't talk to this guard who's behind this bulletproof glass. I take out my clipboard and start making notes. And he's like, what are you doing? I tell him, no, I'm here to do maintenance. So don't worry about it. And he's like getting like more and more anxious. He's like, no, you can't be here unless his boss, right? The boss who who had actually told me that you got lucky. So his boss had made this rule that nobody could enter the premises unless a internal employee sends out an email. So this guy says, I don't have any email telling me that you're coming. Then I was like, oh my God, this was my day off. And you asked me, my boss asked me to come. I'm going to leave. So I started like leaving. He's like, no, wait. Do you have anything else? I said, yeah, in fact, I have this letter that my boss gave me. Then I show him this letter that is actually signed by his boss that asks him to give me access to the office. And now he's confused. He's like, oh my God, like this boss made this rule, and then now he's asking me to break this rule. Like, what do I do? I say, like, don't worry, just call him up and it should be fine. So he calls the guy up, and the guy says, yeah, sure, let him in, right? The mistake the guard did here was that the letter was mine and the phone number on it was also mine. And I just created like a fake letterhead from their company and just signed like some random thing, and my colleague said, yeah, let him in. It was not his boss, it was just my colleague, right? So he gives me a badge, he sends me in, and he says, okay, go ahead. So I walk around, and then there is this operation center that they have, which needs like another set of like you know uh, scans to be done to get in, and you need a special badge for that. So I'm just standing in front of this door now, but it's Friday, and there's like, on a Friday, like there's nobody, like, I can't tailgate inside to get in there. So I just wait there, and then I see suddenly like this guard is walking towards me. I thought it was game over. Like this guy caught me. I'm like freaking out, but I'm like breathe, and I'm like just breathing. And he comes to me, and I'm quiet. Like outside I'm very calm, but inside I'm like freaking out. And he just looks at me, and I'm looking at him like in a confident way. He says, "Do you want to get in?" I said, "Yes." And then he uses his card. He scans his eyes and lets me in. Once I get in, I don't have that picture here, but they had like huge screens, like if you see movies, right? Like this security operations center, they have all these like packets flying here and there, and there are like 6 people sitting, and they all turn back to look at me because there's a small team who's managing the operation center. And because there's a guard behind me, they think, oh, guy might be here for legitimate reason. And they have this printer there, and there's a picture there. It's not clear. It says, do not take pictures. And I made this guard to take a picture of me because I told him that I want my boss to feel bad. Why don't you take a picture and I'll send it to him? So he took a picture of the picture saying that don't take pictures. And then there were like a lot of sensitive documents in the printer. And behind the guard, there was the data center. And this time I didn't even have to ask. I just looked at the data center. He said, yeah, I'll open it. And he opened the data center. I don't know, like there were like laptops open with passwords on, like without passwords, and that was connected to these servers. If I was a bad guy, I could actually like have like transferred like, money and stuff. But I just took some pictures. I just started like, he didn't even ask me why an electrical engineer is typing on like computers on a data center. Yeah, so that was the story of how I got in. But like a lot of people ask, like people feel bad. Did I get this guard fired? I tell like, this could have happened to anybody. It's now that this guy has learned his lesson, it's better that you keep him. If you hire somebody else, that guy has not learned his lesson. Anyway, so this is a good story. It's a fun story, but it is also it also helps you think about the different components. If you look about composability within DeFi, where all these different projects are connecting with each other, it helps you think about like, how to make sure that all these points are covered and all these different places are secure. No matter how secure you create anything, right? Your people are the weakest links, and if you just outsmart the people, then you can outsmart the most secure areas. All right, so now we'll focus on the software side of security and some things that are relevant to Web 2, and we'll also talk about some Web 3 related stuff. So anything you think about from a Web 2 security also applies definitely to Web 3 as well. What are some things, right? You do when you're doing an internal test, you want to make sure the connection between the different components, your database, your web server, your storage, the network is secure. From an external point of view, you want to make sure that the website is secure. If you have a mobile app, you want to make sure the mobile app is secure. And one important thing to remember is that you want to like start educating the engineers, right? It's no longer, security is no longer a security professional's responsibility. As we start moving into this whole philosophy of continuous integration, continuous deployment, where you're deploying things weekly, sometimes daily, or even like bi-weekly basis, it's really not feasible to do like pen tests or security audits of the software at the end of your software development lifecycle. So you want to integrate some of these tooling within your CI/CD pipeline. You want to integrate some of this education within the engineers who are building the products to make sure that they know different security principles, so that you can catch these small bugs as early on in your development as possible. Some of the things that you can do in terms of testing the software is just software composition analysis. So you nowadays, like all the software you build, you can't build everything. You always have these dependencies, making sure that you're testing those dependencies. And there are like well-known like libraries out there of well-known uh, uh, components that already have security issues. So these are like some basic things. You can set up your CI/CD pipeline in a failing mode so that you automate some of these testing and your build automatically fails and you can go and fix those dependencies before you move on. Same thing goes with credential scanning. We see this all the time. Like people are, by mistake, developers are putting their credentials, the SSH keys, the API keys on GitHub or whatever repo you use, making sure that you have like a scanner that actually scans these files to make sure that you're not exposing your credentials. The third thing is a static analysis. Usually, I would recommend doing this in a non-failing mode because it usually has a lot of false positives. So you want to make sure that you just don't get overwhelmed and block your, your software process. And the third part, the last thing is dynamic testing, right? This can be done in a manual way or automated way. Again, this will have a lot of true positives, but it's also the most expensive one. So at least if you don't have resources, I would recommend doing the first two things, which will give you like at least 70% of the security you may need. On the smart contract side, again, like everything that is applicable to Web 2 is also applicable to Web 3. Here also, like, right, like whatever we mentioned in the threat analysis, like you want to create an architecture diagram, you want to build these relationship diagrams between different components, and then create tests, right? And this could also include like thinking about things that are beyond your control, right? If you're deploying a smart contract that is interacting with other smart contracts that you built, and it can also interact with like the blockchain, it can interact with other smart contracts, right? So thinking about where things can go wrong, it can get a little more complicated, as we've seen today with the different hacks that Peter was talking about earlier. So you want to think about those things. And there are other additional considerations to think about, right? Like you have to also think about not only security, but I would think like these other things are also security issues, like making sure that token economics is right, so that not just one person gets more than 51% of your tokens and then create damage. How will like the gas fees affect what you're doing? And how are you doing like ERC20 approvals from your smart contract? So thinking about some of these things is important. Of course, there are automated scanners. You can do manual testing yourself or ask third parties to do it. And I've listed some resources here about how you could go about doing smart contract security. Again, I have no association with any of these companies. I've just listed a few that come to mind. And as I said, like this is something that I've not delved that deep into just yet to give like specific advice here. All right, so now let's talk quickly about infrastructure. How do you want to yeah, I think so. I think gas fee optimization is a serious issue. Of course, for your users, right? It also helps to see how you can think about letting the users know, like because we are so early, like people are paying. Like I think I read just a few days ago, somebody paid 25 ETH just for one transaction. That is like ridiculous. They just made like this mistake of typing in the gas fee. So figuring out how to protect your users from doing those kind of mistakes is also important. All right, so on the infrastructure side, so this applies to if you're developing smart contracts, it could apply, but it mostly applies to if you're using both Web 2 and Web 3 infrastructure. It applies to if you're running a node or a validator for one of the blockchains. So this is applicable for you. of course, like what are internal controls? Like if, for example, if you're using AWS or any of the cloud infrastructure, then you want to make sure that you have reviewed your architecture, making sure that the roles and privileges that you create have the least access, right? You don't want a regular developer to have admin level access to delete things, right? Unless they're doing that kind of work. And also enabling like denial of service protection on your AWS infrastructure. You can also do internal audits. You can create like a checklist. Here, let me share this. I don't know if I can message here in the chat, but let me go to YouTube here. I'll just uh, put the link to the slides here, so you can make. I made it public, so you can add notes there. But yeah, please don't add like some irrelevant things in there. Anyway, so I have this checklist that you could use to validate, like if you're running a server to do whatever work it's doing. I built this for the Cello validators, but you can use it for any other server. Like 80% of the things would apply to you as well. So you would usually like start with a self audit, and then needed you could make like external audits. Again, like same things on the external part of things. You want to make sure that the internal services are not exposed externally. And access, right? How do you access your infrastructure itself? Like making sure you are using certificate based SSH, you have VPN. And if you are a bigger company, making sure that you allow only uh, the people to access certain sensitive information only if they use a company's laptop that is already protected, right? So you could do this using certificates and device trust. There's a question here, and also for sake of re-entrancy attacks, I once lost a lot of EIPs when I was going to decide between. Yeah, it's still very complicated. You and I get confused. You know, I've been in the crypto world for a while now. It's not easy. It's hard. All right, so operational security, who does this apply to? I think this, most of this will apply to anybody, right? It could apply to you as a user. You are non-crypto user, this applies to. It'll apply to if you're a software engineer and doing development. It also applies to if you're a validator or a node operator or a security person. These things will apply. I want to spend more time here on this part of the talk here. So key management, right? One thing to do if you're doing development, making sure your environment variables are protected, right? And also not putting your sensitive like private key information in your environment variables. I've seen like so many teams do this. Like I've advised like so many software teams, so many dApp developers who also use like Web2 infrastructure. So this is a big no-no. Please do not add any, especially you can use like sometimes API keys are still okay adding into your environment variables, but definitely having your private key in an environment variable is a big no-no. You could use a secrets management system. All cloud providers have their own way of doing this key management systems. So you can use one of those, or you could use third-party vaults, something like HashiCorp. On the Web3 side, right? Like if you have more than one people in a team who are controlling keys, making sure you design your multisig in the right way, right? You want to have this M of N keys. For example, if you think about a 3 of 5 multisig, that means that to approve or create any transaction, you need 3 private keys out of the 5 private keys to do something, to take some kind of action. Just making sure that the N, right, the total number of keys is big enough. That way, if you create a small key set, right, like if you create like, I don't know, like maybe like 2 of 2 multisig, then if you lose one key, then you're screwed, right? Like, so making sure that you have enough, right? The N is big enough so that you have redundancy, and also making sure that M is big and not too small to make sure that you prevent an insider threat, right? If you have a 1 of 5 multisig, that is not ideal, right? Any one person within that multisig can be a bad actor and can run away. So you want to make sure that you design it in the right way. And also thinking about hot versus cold wallets, right? How much of your crypto you want to keep on a hot wallet, making sure that that is not a substantial amount, not more than, like, I would say, depending on your project, right? You could keep like anywhere between like 5% of your assets to like 10% or 20% in the hot wallet, and everything is in cold. That way you keep uh, things. By hot, what I mean by hot is if a computer that has your access to your crypto keys is connected to the internet or has the ability to connect to the internet, I would call that a hot wallet. And a cold wallet is putting it in a hardware key or on a device that even doesn't have the ability to connect to the internet, right? That is something that I would call as a cold wallet. So making sure that you protect your keys that way. And then again, like, yeah, of course, you can use Shamir's secret sharing. That will apply more to your, sorry, where are we? Yeah, that will apply more to your multisig, right? When you're thinking about creating multisig, that will apply to that. And of course, sometimes you may have like no choice but to keep your wallet in the hot wallet. So in those cases, yeah, you can think about using those like Shamir's secret sharing to make sure that like the number of M, right? The M of N, the M number of wallets should not add on to be all on hot, right? All the M's should not be hot. Like if you create like 3 or 5 multisig, making sure that not more than 2 of those keys are hot, and making sure that those at least 3 of those keys are cold. So yeah, cool. So yeah, so multisig is just another like way of implementing, right? Like Shamir's secret sharing is a type of multisig. Cool. All right. So then again, like it can get a little complicated, but a lot of times people just get overwhelmed and not do anything. So I like to give really very practical solutions to my clients or my colleagues or my friends of how to do this, right? That is also practical, right? The most secure way to do this would be having a dedicated laptop. It should not even have a Wi-Fi card. Like I have a laptop here behind me. That doesn't even have a Wi-Fi card. I've actually like taken it out, right? I've covered the camera. I have this cover on my camera. I can just close my camera here, physically close it, so that nobody can actually remotely enable, right? Even though I'm a security professional, I'm not like, as, I'm also susceptible to these hacks. My computer is not like NSA grade computer. So I have to take these like physical precautions. If you're more paranoid, you can also block your microphone. That way you don't have somebody turning on microphone. And of course, like blocking internet, right? So this is the most highly secure way of doing your key management and protecting your hot wallet. But if you wanted like a moderately secure setup, you could use your current laptop with a bootable operating system, and but not storing, still like not storing any keys on the laptop. You can use your data on an encrypted USB key that you connect to the laptop on this bootable OS, and then you unlock it and do your transactions that way. And a less secure way of doing it, if nothing, like if you can't do that, it's too expensive, or if it's too time consuming, at least at the very least, right, you definitely should have a virtual machine on your computer that has no access to the internet and that can talk to your host machine and put your keys there. I would advise you to never put any amount of key, no amount of crypto on any hot machine, hot wallet machine. I say that because the crypto today might be like, oh, it's just like $100 worth of crypto, or I don't know, if you're in India, maybe like 10,000 rupees of worth of crypto. Trust me, like within like the next 5 to 10 years, that amount will be huge, right? It could be like $1 million. You never know. So you want to make sure that you're thinking about security from the beginning itself, if you decide to stay in crypto for the long run. All right, so we are at 1:30. We have 15 more minutes. So let's see how much. Okay, so we are almost at the end, and then at the end I'll open to questions, and maybe if we have time, we can have like a discussion with me and RazorSec as well. All right, so on the operation side of things, right? So again, like this is applicable to you, it's applicable to your employees, your colleagues. So how do we protect the laptop itself, right? So I talked about protecting the camera. You can have like make sure that you have full disk encryption enabled. So this is a must, I would recommend. And also creating like admin and non-admin accounts on your laptop so that your daily work you're doing is through a non-admin account, and you want to change something, you add the admin password to change things, and not having non-admin accounts by default, because you can get phished and the hacker will immediately get admin rights to your machine if you get compromised that way. So making sure you're protected from that angle. Also, verifying the software that you download. So this is something that you can't prevent, right? Like I've installed so many software that I have no idea how to find their like the SHA-SUM or the PGP signatures. But doing your best, right? Like doing your best from your part to make sure that every software you install in a laptop is legitimate, right? And browser. So not many people talk about browser. This is something that I recommend doing, is lock your browser down with not more than, I would say, 3 to 4 plugins. These days, we do everything on a browser. You can connect your AWS on the browser. You can connect to the blockchains directly through the browser. So browser is literally the new computer right now, right? And any plugin you install on your browser is like you voluntarily installing a backdoor on your computer. So do make sure that you vet the plugins that you install. So these are some things that I recommend. Web of Trust is some plugin that helps you find out if a website is good or bad. And these other 2 plugins are more on the privacy side of things, uBlock Origin and Privacy Badger. And I've been recommending people, AdBlock Plus is a popular one. I've been recommending people not to use AdBlock Plus because they were doing some shady things. And communication channels, right? Do you want your email to be encrypted using things like PGP or SMIME, and maybe using apps like Signal and Wire to communicate with when you're communicating something sensitive. Of course, logins and password managers, definitely for a password manager, the safest way is having a hardware wallet. I don't have my hardware wallet here with me to show you, but at least having like a file-based wallet, something like KeePass or KeePass XC would be nice. And the least, what is it called, secure way of doing it would be like these cloud-based password managers like LastPass or Bitwarden. I'm a big fan of Bitwarden. It's an open source password manager, which is free, and it's in cloud. It has better user experience than even a paid LastPass. So I highly recommend using something like Bitwarden. All right, so that is from an operational security point of view. Yeah, using tape on your PC is also pretty good. And one note on that is, if you have a MacBook, a new MacBook, make sure that whatever you put on there, it can actually crack. If it has like if its thickness is too much and you close the MacBook, it just shatters your glass. So just be careful when you're using something to cover your laptop. Yeah, laptop. I have like this black tape that I carry. I don't know if I have it here. Yeah, so I have this black tape I carry all the time with me to cover laptops. Who knows where I go next? I always have this to make sure that I cover the laptops. All right, so incident response readiness, right? So this is something that I like to advise everybody to think about it. Is at the very least, right? You should have thought about how to do incident response, even though your project may be small. At the very least, start logging everything, right? if you like, I've done incident response for like 4 years, and worked on like these incidents involving APT groups, state sponsored groups. And every time, like, this is the first thing we look for when we're doing investigations is we want logs. What are like some basic things you could do now? Even though if you don't read it, just create these logs, right? Like the basic things you would need is like who's the person who's taking an action, what action did they take, what time did they take it, and what is the source and what is the destination. So at the very least, you need these 5 pieces of information to be ready with logs in case you have an issue. And again, like having a plan in place, just with threat modeling, right? This doesn't have to be like rocket science. Just creating something on a piece of paper or like notebook like this, and saying, hey, do I have a plan? Like I just write like a plan, like one pager, right? At the very least, making sure understanding who your stakeholders are. Like tomorrow, if you get hacked, right, you don't want to panic and do the wrong things. So today, before you're hacked, making a list of all your stakeholders, all the contact information that you want. Maybe you want, like, if you building relationships with security experts or creating like retainers with these companies who can help you in case you get breached, right? Having these in place beforehand is super helpful, and also helpful to keep your own peace of mind, right? It doesn't have to be detailed, and if you want it to be detailed and you have a project that is like high net worth, you could also do like tabletop exercises. You can hire people to come in and do these uh, tabletop exercises where they come and say, hey, now you're hacked, like what do you do? And then having different scenarios and going through these scenarios to make sure that you are able to respond to these incidents. And that is my talk. I'll open it up for Q&A, but maybe Razor, sorry, I don't know your name. Maybe if you come on stage, we can just have a small chat as well, if there are not many questions.
Hey, Deepak. Yeah, I'm here. A little bit tired, but that's okay. I'm having my chocolates. And where's your coffee, Deepak? How you are
Oh,
so?
I don't.
How you are late?
Yeah, no, people drink a lot of coffee here, but I have this. Water is the only thing I drink.
Okay, yeah,
Uh,
stay hydrated, boys. We need a lot of water to drink, even if we are having a lot of water in our body. But still, we need
yeah,
to be hydrated.
yeah, definitely. Yeah, let me switch off my screen sharing here so that it
Yep,
just asks her on the
yep. That's
thing here.
that's pretty good
All right. So I mean, people. I'll wait for people to ask questions. Not. I'm also interested in how are, like, how is like security progressed in India. It's been a while since I've lived in India, although I travel to India a lot. So maybe I can ask you some questions. But let's wait for other people to ask any questions they have.
Okay, so Changes is saying awesome stuff, Deepak. Enjoy the stories and the solid recommendations for key security.
All right. So yeah, do you have any question for me? Otherwise, I'll ask you questions. I would like to. uh,
Yeah, sure.
so yeah, I'm just curious, like how is the awareness of security within India, and more specifically around blockchain, right? How are things progressing in India?
Okay, so right now we are still finding ways to bring blockchain security in India. Basically, what kind of phase we are going through in India is people are talking about either blockchain or security, not on blockchain security. So there
Yep.
are two different aspects. So either they will be talking about cryptos, bitcoins, ethereums, or either they will be talking about like web security. Got it? Like, and it's not like something attack vectors from blockchain, like how you're gonna secure your blockchain if you're using it in your infrastructure. What will be the recommendations for you and your infrastructure? Like as I said in the very first session, blockchain was introduced as a kind of security measure, as a kind of security, like blockchain isn't it itself secure technology, right? But still it got hacked. The famous DAO hack that we remembered, uh, uh, that re-entrancy attacks that exploited the functionality. So yep. So we still need to bring more people. We still need to share this info. We still need to bring people into our community. Like share more and more information. Do events like UnChained that we are doing. Bring more people, more security researchers like you, to share the word and bring people together. That's what RazorSec is doing. We started a community like an year ago, and we created a server for the same purpose that will bring security researchers from all over the world and will help each other. We'll talk over blockchain security and we'll learn and from each other and grow together.
Wonderful. And where are you based out of?
Right now, I'm in Mumbai.
Got it. So I'm guessing like what are the hubs, right? Like Bangalore is a hub for
Mhm,
crypto. Bombay is one
mhm.
as well, and maybe Delhi. I don't know. What are the hubs where people are building?
They are basically Delhi, Mumbai.
Yeah,
The major cities you can say the companies are using blockchain in this infrastructure, but it is not being revolutionized in India.
yeah.
So
Also,
it
I
is
think
still waiting for that spark into the public. So okay, they need to shift to dApps and they need to build applications on blockchain. So that kind of spark we still need in India.
yeah. I think like yeah, at least younger people are getting into
Mhm,
blockchains. There is also like this, like me. I have like some ideas. I want to come to India and build it, but there's like regulatory uncertainty, right? So I think that is also playing some part in that. No,
right. So, Venably, when you will be coming back to India?
I was planning to come in April, no, May of last year, but the whole COVID happened. So, but I will come like after sometime after April. I would love to come, maybe come to Bombay and like see
Yeah,
how
sure. Please
people
do.
explore.
Uh, we'll host another event together there, and like we'll do some workshop as well.
Yeah, let's do it. Excited. All right.
Right.
Any
So,
questions from the audience? Like, would love to see if any comments. So
uh,
there are some comments about DeFi projects are taking care of security, like smart contract audit. Okay.
mhm.
So,
Yeah, one more thing. We will be having a DeFi panel over DeFi security like on 27th. That is today itself, according to IST.
yeah,
So we would love to have you with us in the panel as well if you get some free time. What say?
sure. I'm just looking at, is this the, when is this? I'm just looking at the list here. DeFi panelists, 3:30 to
Mhm.
4:30 p.m. IST. Oh, it's 5 a.m. for me, man.
Right. Yeah.
uh, I
But
don't know if
uh,
wake up that
it's
early.
okay with IST, right? It's more good for you if you follow the IST, right?
No, I'm in EST, so it's 5 a.m.
Okay,
for
you're
me.
in EST.
Yeah.
Yeah. So yeah, that will be a very early morning for you.
Yeah. If I wake up, if I sleep early, I'll join. No promises, but would love to talk about DeFi because uh, that is the other interest that I have. I do DeFi all day as well. Uh, like Cello blockchain is literally like a blockchain built for DeFi. So it's
Then definitely we would be very eager to listen some words from you
yeah.
about what kind of DeFi security we can bring from the Celo.
Oh, okay, yeah. So from a DeFi perspective, I'm more a DeFi user. Like, not I can't talk about. I don't know much. I've not studied that much about DeFi security itself. Uh, but I could like,
Okay.
yeah. I'll let you know if I can make it.
Yep. So I think there are no questions from the audience. Is there
Oh,
any
so
question?
there
Yep.
is one. What do you think needs to be done promoting blockchain security in India, except blockchain-based startup? It's the same thing, right? Like, what do we need to bring this awareness, right? I think the crypto industry itself as a whole is not yet matured enough to have security, right? Like the not even like a lot of blockchain companies, like big blockchain projects, don't have a security team, right? We at Cello like decided to create. We don't even have an IT team. We hired a security team. I was the first like full time guy at C Labs doing security, and now we have a security team that is also doing IT, right? So there are projects that are bringing security, but mostly it's not like not everybody's thinking about security in this space because we want to like build tools, right? Like the builders want to build fast and create like get this uh, product market fit, and they don't have time to think about security. But as we get more and more awareness of all these hacks, I think we will start thinking about security. And of course, like I'm biased here. What blockchain is best for DeFi? Celo is best, and of course Ethereum, right? Ethereum is the godfather of DeFi. So yeah, definitely Ethereum is like the best. They have liquidity and everything there. So Ethereum would be the best for that.
But you guys are doing a pretty good job as well. So best wishes for you.
Yeah, thank you.
So that's all from the audience. So someone is asking like which blockchain you prefer. Okay, that is done, I think.
Yeah, I like Cosmos as a project. They are a huge ecosystem, and they are doing building things in a thoughtful way, right? I don't want to be here into speculating about what cryptocurrency will move in tomorrow or not. But as a project, apart from Ethereum and Celo, I like Cosmos a lot. They are very thinking about not just from a technology perspective, they're also thinking about we as humans and how to think about sustainability about Earth and how to make sure, right? Like they're doing like some really inspiring work in the similar ways of how like Cello is doing. Like we are thinking about the mission of wanting to bring the financial tools for the world, right? So yeah. Anyways, don't want to go too deep into non-security related stuff. Uh,
So I think that's all from the audience. No more questions, right?
all right,
I think
wonderful then.
that's all.
Yeah,
So it was a wonderful meeting with you, Deepak, and like gaining so much knowledge from you over the Web3 security world. And definitely, people will be emailing you about that free coins from the Solo,
yeah,
and we'll be talking about how they can collaborate with you over building projects.
wonderful. Yeah, please reach out. If not, thanks for hosting me, and wish you all the best. See you.
Thank you so much. Bye bye, Deepak.
Bye.
Hey Nick, welcome to the stream. Can you hear me?
I can, yeah. Thank you for having me.
Yep. So, how's you, Nick?
I'm good. Yeah, I'm doing well. Seems like the conference has
So,
been going
what
quite
time
well.
is there? What time is there at your place? It's
It's
having
like
like 12:30 a.m.
midday.
here, right?
It's midday here.
Oh, it's
It's
midday here. All right. So we all are pumped up and we all ready to cheer you up for your session, and I'm pretty excited for it as well. So I can turn your screen share on here. So right, it is visible. I'll be putting myself off here.
awesome. Thank you, and thanks again for having me. This has been a cool event so far, so it's good to be here. My name is Nick. I work on smart contract security at Consensus Diligence, and this talk today is kind of born out of a side project, which is a multi-sig written in EVM bytecode, and then along the way, exploring some different tools and techniques for a sort of deeper smart contract development process, and potentially talking about some other options for that as well. So I'm going to give a brief introduction as to why we would want to use some of these techniques, and then a very brief introduction by example to some of the tools that were used in this project specifically. A good place to start, I think, is to converge on a common definition of a smart contract, at least for the purposes of this talk. Martin Lundfall, last year at ETHCC, gave a great talk called Smart Contracts as Inductive Systems. And in it, he discussed more deeply this question and the implications of what definitions we might decide on for a smart contract. He ultimately settles on a definition of a smart contract as an initial state, together with a finite list of stateful functions that operate in a context of other stateful systems. Some interesting things to note from this definition specifically is that we're primarily interested in the stateful functions of our smart contract, and these functions are stateful not only in the sense that they depend on the state of our smart contract itself, but also on the state of this environment of other stateful smart contracts and on the state of the blockchain as a whole. What I really want to take from Martin's talk, though, is this image of a smart contract as this tree of possible states that our smart contract can take on. And we start from this base node, which is the initial state given by our constructor. And then we have a tree of all of the states that are reachable from this initial state. And so by this definition of a smart contract, we can kind of talk a bit about what it means to have an incorrect smart contract. So you could certainly argue about the definition of an incorrect smart contract, or whether an incorrect smart contract is even something that's possible. But in my mind, it means that it is that the behavior of the smart contract differs from what the programmer intended. And so in some way, this tree is different from the programmer's understanding of the smart contract. And so we have a kind of real smart contract and a smart contract as the programmer intends it. And our real smart contract is determined by the bytecode in combination with the execution environment. And the reason we include the execution environment here is that you could imagine a situation where we have one piece of bytecode that doesn't change, but we have a hard fork, or the rules of the EVM change for some reason. And this changes the smart contract. It changes the possible states that this smart contract could be in. A more interesting example of this, I think, is layer 2. If you take a roll-up, for instance, depending on how your optimistic rollup is implemented, if you want to prove fraud, you potentially deploy your smart contract on layer 1, and then the fraud prover interprets that smart contract according to the rules of your layer 2 execution environment. Whereas because the contract exists on layer 1, you could also interact with it on layer 1, in which case it would be interpreted according to the rules of the EVM. And so we now have a single address and a single piece of bytecode that is interpreted in 2 different execution environments and gives us 2 different smart contracts that in some sense live at the same address. So when we talk about security of our smart contracts or correctness of our smart contracts, we want to do a better job of merging these 2 trees, this tree that is defined by the bytecode in the execution environment, along with this tree as our programmer understands it. And so one way to do this is to focus more on thinking about what our code should do and what properties it should have, and then also making some effort to confirm these. And this is intentionally quite general. So depending on what your goals are or on the purpose of your smart contract, you might do these things at varying levels of depths. And there's lots of different ways to do them as well. Demo and Yoran talked earlier today about Scribble, which is a great language for expressing properties that your smart contract might have, for thinking about what your code should do. And it also injects solidity and gives you an opportunity to confirm these things. So you can do that through your tests or through fuzzing or through some other tool. But there's lots of tools that we can use to do all of these things. And one of the more important tools that we don't mention here is the tool that you use to build your smart contract. And in most cases, this is Solidity or some other high-level EVM language. And we too often fall into the trap of reasoning about our smart contract in the language that we build it in, which is certainly easy to do, but we also need to understand the purpose of the languages that we're using to build our smart contracts. And this is Rune's famous $E post, which is what ultimately became MakerDAO and the DAI credit system. And in it, he raves about how easy it is to build on Ethereum. Specifically, he's talking about Solidity here. And this gives you a good sense of where the Solidity programming language came from, why it looks so much like JavaScript, and why it was so important for web developers to be able to pick it up and build quickly on their ideas. And really, the priority was that lots of people should be able to easily build a program. And the idea that it should be difficult to build an incorrect program was really not a priority at the time. And so being able to look at kind of the evolution of Solidity, and to be fair, Solidity's goals have changed quite a lot over the years as Ethereum has changed and as the priorities of smart contract developers have changed. But Solidity is not always the right tool for reasoning about our smart contracts. And to give a concrete example of this, it is a security conference, so let's look at a bug. And this is an example multi-sig contract where we take some action and we take a gas price to reimburse the relayer at, and then some signatures over this action and gas price. And then we meter the gas and we check our signatures and we execute this action and then reimburse the relayer for the gas that they've spent on this. And there's quite a subtle bug in this, which is that when we call this validate signatures function, we are implicitly copying these signatures from call data into memory so that we can pass it to validate signatures. And we only validate threshold number of signatures. So if we require 3 valid signatures to execute an action, then we only check the validity of the first 3 signatures, but someone might pass in more signatures than that. And in fact, an attacker might pass in a huge amount of 0 call data and force us to copy that call data into memory here, and then get reimbursed for up to the entire black gas limit. And they can repeat this attack for as many sets of valid signatures as they have, and potentially drain our multi-sig. So this suggests one example of something that Solidity is not right for reasoning about, which is resource consumption in the EVM. To move to this multi-sig project that I mentioned, we're going to talk about some other tools that we can use to reason about things that maybe are difficult to reason about in Solidity. And what we really want from these tools is to emphasize different parts of our smart contract, where Solidity gives us one vision of our smart contract, but we want to look at it from different perspectives and use some techniques that emphasize different pieces of it. One of those is a design level specification. In this case, it's written in K, but you could really write this in a number of different languages. You can use some tools that give you useful information about your design, but you could also just write this as a natural language specification. Write it in English or whatever the common language of your team might be, but put it to paper and write down what your smart contract should do. And this is one piece that I think you could argue that having multiple implementations, particularly an implementation in Huff, and doing this bytecode level specification or formal verification is somewhat idealistic. But I think this design level specification is something that every project should be doing. This is an incredibly useful tool, and it also is relatively simple to do. We also have, in this case, multiple implementations. There's a Solidity implementation, a Viper implementation, and the one we'll be talking about today is the Huff implementation, which is Huff is an EVM assembler, and it really just gives us a bit of sugar and a bit of a better experience in writing smart contracts in bytecode. We'll also talk about K at the bytecode level. This is using the EVM semantics in K to formally verify our program. So the K framework, as you might have heard of it, if you heard of the K framework in the context of Ethereum, this is probably what you are aware of, which we take these EVM semantics, which is the rules of the Ethereum virtual machine. We feed it to the K framework, and it generates for us correct by construction tools, such as a compiler, an interpreter, and the one that we're really interested in Ethereum typically is this deductive program verifier. This is what we use to formally verify smart contracts. But in this case, we're going to actually write our model of the design level of our smart contract as a semantics itself. And then we're going to kind of gloss over these tools that are generated. We're going to kind of ignore those for now. We're just really going to use K as a modeling language. And to do that, we first have to define a configuration. And this is the environment of our programming language. This is where we define the state of our smart contract. So the interesting cells here, where each one of these XML-like cells contains some important piece of the state of our program. And so we have a nonce, we have a domain separator for EIP 712 signatures. We have some threshold, some minimum number of valid signatures that we need to execute an action. And then our smart contract has a balance and a list of valid signers that can approve transactions. And you'll note that we don't specify anywhere here where these are stored. So actually in the Solidity implementation, much of this is in storage, whereas in the Huff implementation, most of this data is sort of jammed onto the end of our bytecode. And we want this specification to be valid for both. And so it's nice that we can kind of abstract that away and ignore that piece of the implementation. This EBNF-like notation we use to define the syntax of our programming language But in this case, the important thing here is that this is kind of the programming language that we're defining. This is what a statement for our design level specification looks like. And this might look familiar from a kind of Solidity-like syntax. We want to use the execute function in this case, and we give it some gas, or we can specify the sender of the transaction, and then we pass in our function parameters. Once we define the syntax, we then have to define the semantics. What does our smart contract actually do? And so we have these small step state transition rules, which say things like, for instance, this is a state rollback rule. So this is something that we don't think much about in the EVM. Whenever an execution fails or we hit a revert opcode, we roll back our state to the previous state. And this is just doing exactly that, but kind of encoding it in an explicit way. So we have this pop state, and this K cell is kind of just where the action happens in K. This is a K specific thing. And a pop state rewrites to the empty K cell, meaning that we just move to whatever is on top of the K cell after this. And at the same time, the state of our smart contract, so this whole group of subcells over here rewrites to whatever it was at the beginning of execution, and then we drop the state, this saved state that we had from the beginning of the execution. So to look at what one of these rules looks like for the constructor of our smart contract, how do we define the initial state, this base node of our tree? This is the constructor. You can see it takes 2 arguments. It takes a threshold and a number of signers. And what we want to ask in a specification like this is things like, well, can our threshold be 0? Can we have a multi-sig that doesn't actually require any valid signatures to execute an action? And in this case, we say no, our threshold has to be greater than 0. And in fact, it also has to fit within 1 byte. It has to be less than 2 to the 8th. Some other things that we are forced to explicitly encode in this specification is the balance of our smart contract. So we take some call value, and there's no restrictions on this call value, meaning that this could potentially, meaning that our constructor is payable. This can be 0 or it can be non-zero. But we also might have some initial balance in our smart contract. For instance, if someone had predicted the address of this future deployment of the multisig and had sent some ether there. So this balance is going to stick around, and we're going to have both the original balance added to our call value is going to be the new balance of our multisig. You can see that there are some restrictions on this, so that the sum of these two, the balance and the call value, has to be in the range of 2 to 256. But we don't actually specify an alternative to this because it's unlikely that we'll have a case where the total ether in our account will overflow. So using K as a design specification tool like this, it gives us a very precise language to reason about our contract at this high level. It's also executable. So we can test the specification. And in fact, in testing our specification, it reveals some interesting edge cases that we might want to test in our implementation, because we can simply test every K rule and use that as a test case for our implementation to make sure that we cover our corner cases. We can use this to specify the system at any level of abstraction, so we could ignore things like optimizations or intricacies of the EVM, but we could also include those in our model if we wanted to. We don't get a lot for free from this, from the K tools, but K is pretty powerful if you want to put in the work, and you can do some interesting things with this, potentially generate solidity. You can prove sort of system level invariance about your design, and then you could even prove, if you have a bytecode level specification, that your design level specification, or that your bytecode level specification is a refinement of your design level specification. To move to Huff, which is the implementation that we're going to talk about. Huff is an EVM assembler. It's really not a programming language, in that there's no functions or variables, there's no checks. It sort of gives you just a way to simplify some of the tediousness of writing raw bytecode, like recalculating code offsets and jump destinations and dealing with control flow. So we'll look at how we implement this requirement right here, that to go back to our K specification, or our design level K specification, this requirement that the threshold is greater than 0 and less than 2 to the 8th. So this Huff right here is a macro, and we want to validate our threshold. This takes one item off the stack, and we can see this is just a comment indicating that this item on the stack that we're expecting is the threshold. It also takes a template argument, which is a destination to jump to that will revert in this case. And in this Huff macro generates some bytecode. And if we disassemble that bytecode, we can see that it's really quite similar to the original Huff. Huff does not really do anything on top of what we're telling it here. Although maybe this throw destination here, this insertion of the template argument turns into a push onto the stack of this jump destination. And then this hex literal gets turned into a push instruction that is as small as possible to fit the hex literal. If this was a 2-byte hex literal, this would turn into a push 2. This is a single byte, so we have push 1, 0xf. F is what we get out of this. To move back to the K, and in this case we're actually talking about what most people refer to K related to in the Ethereum space, which is we take this EVM semantics, we give it to the K framework, and then we use this deductive program verifier to verify an EVM program. So this is a specification of our nonce function. This is just a public getter function that loads our nonce out of storage and returns it in return data. This is an abbreviated specification. You can't prove this. There's actually, I think, something like 60 or 70 cells in the actual KEVM configuration. But here you can see that we have a similar configuration to what we had for our design level specification, except for these cells in the configuration are parts of the EVM. So for instance, this ID represents the address that we're executing code in, and then the program represents the code that we're executing at this address. There's some notion of a caller and some data that they can provide in call data. And then of course they can provide value to the call. The call has a certain amount of gas that it consumes through the execution. And we see these rewrite arrows again. And so what we're asking of K in this case is we want to prove that everything on the left side of this, one of these rewrite arrows, or everything in a cell without a rewrite arrow, is our initial state. And we say that whenever the initial state of this specification matches, then we will ultimately end up in the final state of the specification, which is everything on the right of one of these rewrite arrows, or everything in a cell that does not contain a rewrite arrow. So we kind of split this into an initial state and a final state. And then we say that this is the state transition that we want to make. We want, for instance, our output cell, which is the return data cell in the EVM. It starts as an empty byte array, and it rewrites to our nonce. And this nonce actually comes from storage at the address we're executing code in. Storage slot 0 of that address is our nonce, and it gets rewritten into this return data cell. And then the status code here means that our execution always succeeds given this pre-state. And our gas, this underscore means that we actually don't care what this is. It can be anything, but we are allowing it also to change because it starts as some value v gas, and then it ends as something that we don't care what it is necessarily. And we restrict v gas in this case to greater than 5,000. We can be more explicit about this. We can actually use K to extract a gas expression and more precisely define what the value of our gas is going to be, or how much gas this function is going to consume. But here we just we make it more general, and we say we just have, as long as we have 5,000 gas, then this transaction will, or this call will succeed. We also say that we cannot have call value. So we see in our call value cell here, we take this as v call value, and then we restrict it to be equal to 0, meaning our function is non-payable in Solidity terms. If we wanted to prove that this function would revert anytime call value was greater than 0, we actually would have to write and prove another specification. So you can see this is quite low level. Some of the other cells in the EVM are things like the program counter and the stack and the memory. So we can prove things at a very low level, but we also have to specify them at a very low level, which can be a significant amount of work. But what we get out of this is that we get a proof from KEVM that says anytime we have this pre-state, we can guarantee that it will rewrite to this post-state, and ultimately that helps us prove that our program meets the understanding of it that the programmer might have. So some final notes on this stuff. It certainly is idealistic, but I think that you could argue that this is not something that many DeFi projects these days are going to do, when you can launch a project in a week and have 500 million in it by the end of the week. But I do think that it's worthwhile for more projects than you might think. And it's going to be increasingly demanded, I hope, by users. But it's also important to remember that this is not an all or nothing security approach. You don't have to write 2 or 3 specifications and 3 implementations of your smart contract, or else do nothing. Right? If you can pull in one of these tools, or pull in a different tool to achieve one of these things, to reason about your smart contract in a different way, that everything that you can do is a gain towards security, and it makes a big difference. I also think that we should spend much more time not thinking in terms of Solidity. In fact, I would say we should spend the majority of our time not thinking in Solidity. And this is not because Solidity is a bad language, because you can write buggy code in it. But we don't want to fall into the trap of doing all of our reasoning about our smart contract in the language that we write it in. We want these languages we want the different languages or techniques that we use to emphasize different parts of our smart contract and give us a different perspective on it. And when we talk about specifying our smart contract, about what our smart contract should do, we want to make sure that we're encoding all of our assumptions about that smart contract, and also making explicit our understanding of what the smart contract should do. And even just doing that, I think many times reveals bugs that we would not have otherwise found. I also think that we shouldn't shy away from attempts to make the EVM safer, or to give ourselves tools at the EVM level that make it easier to write secure smart contracts. This is something that what was done quite a lot. I think it's easy to forget that some opcodes that we take for granted now as very necessary to write a secure smart contract, things like return data copy or return data size, they were not originally part of the EVM. They were added because we realized that these things could make it easier to write secure smart contracts. This has kind of fallen out of favor. In the Berlin hard fork, we'll see EIP 2315 go in, which is native subroutines in the EVM. I think that this is sort of a step in the direction of getting some momentum behind changes to the EVM that might make it easier to write secure smart contracts. And I think we should keep our foot on the pedal in some sense. If you want to learn more about this project, it's called the Minisig on Wolfflow on GitHub and Wolfflow0 on Twitter. Some other work that you might be interested in, K and KEVM, are maintained by the Create K framework team. This is their website, and the Jello paper is the EVM semantics. It's presented in a sort of nice way. The ACT specification language is something that you should definitely check out if you are interested in the things that we modeled in K and in KEVM, but maybe want to use them in different ways, or you just want to get rid of this XML-like syntax. ACT is a sort of nice, concise, smart contract specific specification language, and from an ACT specification, you can generate a K specification. But they also have some other backends in the works so that you could use this with other proof assistants or SMT solvers. Suhaib Bugrara of Consensus R&D wrote this paper, which is quite interesting if you want to learn some more about the K framework and using it to verify smart contracts. And also, I borrowed heavily from it for this project and also for this presentation. Actually, Suhaib, in this paper, formally verified a modified version of this simple multisig. And these are two multisigs that partly inspired this project. So Christian Lundqvist, sort of immediately after the first parity wallet hack, wrote this simple multisig. And at least in my mind at the time, it was kind of a major jump in the way that we thought about smart contracts, because it was one of the first smart contracts to leverage EC recover in this way, and to take all of these signatures and call data, verify them in the smart contract, and then turn the smart contract into a sort of single state transition, as opposed to everyone interacting with the smart contract and forcing us to have these partial state transitions in our multisig. Nick Dotson wrote a very similar multisig, which is quite interesting because it's written in Yule, which is neat. If you want to learn more about Huff, it's built by the Aztec protocol. It's really not maintained by anyone, but I think if we had some users, we could get an effort behind it to do some maintenance on it. If you want to see another cool Huff project, or if you're interested in rollups or layer 2 stuff, Dylan Keller's EVM hypervisor is a very cool one to check out. And that's all I have. So yeah, thanks so much for having me, and I'm happy to answer any questions.
Hey, Nick. So that was a very informative session from you. There are two questions right here. So I think one you already just answered. Someone asked, where can we learn more about Huff? So you showed some slide, right?
Yeah, so just going to the Huff repository is probably the way to do it. Here it is.
Okay.
And
so
there's also a Discord channel.
Right. Another one is like someone asked, what's your favorite decompiler?
I just use the decompiler that ships with Geth. That's like the EVM command line tool. But I'm sure there's some great ones out there.
Yeah. So we'll just take 1 or 2 more minutes from the audience if they will be having any kind of questions. I think nobody's having any question. I think that's okay for our session. So once again, thank you so much, Nick, for joining us as a speaker for our blockchain security conference. and it was a very informative session, like how we can shrink our smart contracts. I hope people definitely have learned a lot from the session and will be reaching out to you uh, to gain more knowledge on this topic. And yep, thank you once again. See you in our
Great.
next
Yeah,
event.
thank you so much for having me.
Yep. So see ya. See ya, Nick. Bye bye.
Cheers, everyone.
Hey, Michelle, can you hear me? Hey, Michelle, can you hear me?
I can. Can you hear me?
Yeah, you are properly audible. So we'll be going on air within just 5-10 minutes. And yep, everything is working fine. Uh, what time is it there at your place, Michelle? I think he will be joining in 5-10 minutes. And my teammate told me my eyes are looking a bit tired, so I'm gonna wear my goggles on. I hope. I don't think so. It works any good for me. But okay, let's wait for Michelle to join back in.
You know?
Hey Michelle, yeah, I can hear you. Yeah, I can understand. Restream kind of show its faces, so it might be a difficult thing. So is it working fine now?
I think it's working fine now. I disconnected from my VPN just to make sure this would work. Okay, cool.
Yep, everything is
I
working
should be
fine.
good to go. And then for the share screen, I just use this retool button here to go to my presentation, correct?
Correct. Yep.
Perfect. I guess I should share my screen first.
Yeah, you should. I will get a window here. Yep, I got it. So I can switch the layout here. Give me a moment. Got it. And I will turn myself mute and go off here.
Let me know when I should be on screen. Or I guess I'll go view.
Yeah, sure. You can go live right now. I'm just putting myself off here. So the stage is
Okay.
all yours.
Cool. Can they see me? Hey, everyone. My name is Mitchell Amador. I'm the CEO of Immunify.com. We are the biggest bug bounty platform for dApps and especially DeFi applications. And I want to share something a little bit weird, namely why I think that the needs for smart contract security in general, but DeFi in particular, are going to be driving our industry to the point where you're going to have $10 million bug bounties. I know that's a pretty crazy claim. Seems out there, but I want to go and walk you guys through it, substantiate it so that you can get a little glimpse into what the future is going to look like. It's going to be very strange, but for those of us who are in the security industry, we have great contributions to make. We are a pivotal part of realizing this decentralized financial future, and there will be corresponding rewards for that, which are not, obvious today. So let's dive in. Okay, so our thesis at Immunify is that bug bounties are kind of like a very effective generalized way for securing dApps and DeFi applications. And the space is so young and nascent that you have very few tools for doing that effectively. So what we've already found in our business and what we bet is going to continue to happen is that more and more projects are going to be using bug bounties to surface major vulnerabilities. And because there's so much on the line, these bounties are going to be absolutely massive. So what does massive mean? Well, we suspect that massive means bug bounties in the millions of dollars are going to be the norm. That in 1, 2, 3 years, any DeFi project with more than $10 million in total value locked or TVL is going to be considered irresponsible from the point of view of security best practices if they don't have a bounty that corresponds to the amount of user funds at risk. Like there's going to be no other accepted behavior than having a correspondingly large bug bounty. This is, of course, a huge difference from the way bug bounties are done in web security today. Certainly in all security, but especially in web, if you have a $20,000 critical bug payout, that's a big deal, right? That's amazing. That's could be a whole year's worth of wages or more, depending on where you live. But in the land that we're working in with DeFi applications, that's totally insufficient to cover the security needs to incentivize people to disclose. And if you guys are curious, wow, that's a big claim. You're telling me that bug bounties are going to be huge. Why should I believe that? Crypto has already been moving this direction in general. Like we've been moving away from web dev sized bug bounties. You can go to immunify.com right now and you can see that the average bug bounty size for a critical bug bounty for crypto projects in general, this includes DeFi, this includes dApps, this includes wallets, this includes exchanges, is $43,000. Now we're accelerating that at Immunify, encouraging that because it's a more effective way. And on Immunify, the average bounty size for a critical for our projects is $98,000. And we've already paid out millions of dollars in bug bounties. So we are, very sure that this is going to be the future. And it's just one way in which security is going to be taking center stage in decentralized finance. But let's dive into specifics. So the first question I always get is like, wow, that's mind-boggling. That's such a shift in reference that seems so foreign, so alien. Why are the bounties going to be so large? What's going to be driving that behavior? And the core of it, the core driver that drives everything else, is just the sheer amount of money and wealth locked in smart contract applications. This is especially so for DeFi. So we're looking at about $50 billion in TVL presently. And remember, it's crypto. So all of those assets are basically bearer assets, and bearer assets are the best and easiest things to steal. So when you have that kind of need, your incentive to be an attacker, to go and break these contracts, now goes sky high. It makes sense for a criminal organization to build out, a hacking apparatus just to go after DeFi contracts, because your payoff could be $40 million. We saw that 2 weeks ago with the Alpha Mora hack. I believe the total amount stolen was about $38 million. We had a similar event late last year in the fall with the attack on Harvest Finance. That was for $30 million. That is the norm. The hacks are going to continue. They're going to increase in frequency, and they're going to get larger and larger in size. And it's all driven by the fact that there's a huge amount of money that's locked up in these contracts and that are relatively easy to steal. Now, the incentives, of course, to defend those is increasing sky high, and that's going to be the flip side. As these attacks increase, people who run these projects, protocol owners, DAOs, communities, are all going to be realizing that, oh, wow, we need to do literally everything we can on the security front, because if we don't do it, it's basically knowingly taking the risk of certain death. And so they're going to getting more audits. They're going to be getting more code reviews. They're going to be seeking out the best and the best of auditors on retainer. They're going to be experimenting with new products, and they're going to be using bug bounties as the most generalizable and cost efficient of all of those tools. And this is going to be the primary driver, right? When you have, let's take a good example. We have client Badger DAO. They have about $2 billion in TVL that we're helping them protect. Today, their bounty is $500,000. I have every reason to expect that number is going to increase, right? As the security concerns get tighter and tighter, stronger and stronger, and more hacks happen, because you can't take the risk, and you're willing to pay a very significant amount of money in order to make sure that if anybody finds something, that they're going to disclose it, and disclose it responsibly. TVL keeps rising, projects keep launching, things keep going faster, but the security standards of these projects, the amount of high quality code review that is being done in the industry, that's possible to do in the industry, is increasing linearly, whereas the amount of projects in the space and the amount of TVL in them is increasing exponentially. So this is a mismatch that is going to guarantee, a huge increase in the number of hacks and money stolen this year. And that's what's going to be the main driver for bug bounties. Now, that is the core thing, right? So just the sheer amount of money, but it's compounded, right? There are further factors that push up the values. First and foremost is the small size of the teams. So, the mStable team has 6 to 10 people. They have 40 million in TVL. They could do a lot better in the next few years. They're building a great product. I expect them to. When they grow, when that TVL grows, their team is not going to be able to grow with it. And so they're always going to be limited in terms of bandwidth. Like, there's just not extra resources to go and to adopt new security practices. So, the problem that a lot of these projects face is they're faced with all this new TVL, but their teams are super small and they're now busy all the time. Their only choice is to throw money at these issues, and the obvious place to throw them is bug bounties, where you don't take any upfront risk. So that's what they're going to do. That's what we've already been seeing at Immunify. Additionally, further compounding issues, your ability to fix these problems is very limited. It's not like there's any equivalent to, say, endpoint protection in DeFi, right? These attacks happen near instantaneously. You don't really have a chance of doing an effective emergency response. It's difficult to imagine how you would stop an attack while it's happening. This is why war rooms are such a thing in DeFi, because the moment you know of an attack vector, the moment you identify, you've done a proof of concept, you know it's viable, you war room right then and there to prevent it, because if someone else has already figured this out, like when he executes that attack, there's no way to stop it. And like the sum up of that is just basically on-chain products, which is where all this capital is aggregating, are very, very hard to defend. And this is, compounded by a third factor. So smart contracts are really hard to change. We see this especially with the permissionless products. So we had a client, Primitive Finance. We had to do a preventative white hack on them, effectively stealing millions of dollars that we then gave back to the users because there was no off switch, right? It was a permissionless contract. There were no admin keys. There was no multi-sig. So, someone gets something wrong in a protocol like that, and you're done. Another great example of a project like that is Tornado Cash. There's no off switch in Tornado Cash. If there's a vulnerability in Tornado Cash, they're done. It's over. That's very, very common. So all of those are going to dramatically increase the incentives to create larger and larger bug bounties, because if you don't create this reward for surfacing these vulnerabilities, the consequence of not having that settled, the consequence of not having that vulnerability revealed to you in time, is a total destruction of your project. Pretty severe pressures. It gets worse though. So on the smart contract side, there are a variety of problems, of course. The complexity of these contracts is increasing by the day. So we're building all sorts of new financial primitives in DeFi, but this creates new issues. For example, I don't know anybody in my network who thought flash loans were going to be the attack vector that they proved to be over the last year, except as something theoretical. And they turned out to be crushing. What's another good example? Token approvals. So tons of DeFi applications, tons of dApps require you to give approvals on allowances for use in the applications. You leave those on, and that's a major attack vector. I know when we were dealing with the Primitive Finance white hack, one of the risk factors we saw was we could drain funds via the token approval system through that method. So there have been a number of scams in that area already. There will continue to be more and more hacks. The composability is fantastic for building great products for users, unquestionably, but it presents an entirely new set of risks, and those risks are kind of unpredictable. And that's before we get to the classic systemic risks. So just like when you have a series of over-leveraged banks or credit institutions, if one of them goes bust and they don't have enough collateral to back their loans, then you can create this chain of collapse, basically, through the financial system. We don't know what's going to happen to us in this area because we've over-collateralized almost everything in DeFi. But eventually we'll have similar risks as more and more dApps are connecting to one another. And a failure in one will create failures in the other. This is clearest when we look at Oracle attacks, right? People are going and doing serious ARBs, effectively financial attacks on a variety of systems by manipulating their oracles. None of this is going to go away. Like these few examples I gave you are not just what the current state is. They're a trend. And the trend line is the amount of possible vulnerabilities in smart contract apps and DeFi applications is going to be increasing significantly. Every new innovation that we create in the space, which is a lot because we're all very busy working away, creates new opportunities for skilled cyber criminals to leverage them and manipulate them. And that risk is just, never going to go away, at least not until we have dramatically more mature tooling and services. And the result of all this, let's tie this in a knot, because that was a lot of words. You've got tons of money, right? Tons of money locked up in these contracts. It is easy to steal, easy to move, right? You can do it very discreetly. It's hard for someone to catch you while you're doing it. You combine that with no one's really sure how to secure these dApps. There are best practices, yes, from players like Trail of Bits and Consensus Diligence and various tools, and they're great. But there's nothing definitive. Like you can't have 100% certainty when you're working with these DeFi applications. Now, due to the nature of Ethereum, certainly I think all on-chain environments are going to be the same. We've seen similar vulnerabilities in Tezos and in Tron as well. default tolerance of these DApp applications is incredibly low. If something goes wrong, it goes really, really wrong. So you're having a good day, you're building away. If you messed up a very minor thing in the code, you effectively open yourself for something that could instantaneously destroy your project. These combination of factors is incredibly, incredibly dangerous, right? We have created the world's largest honeypots for people who are willing to crack new and relatively untested technology. And nobody's entirely sure how to protect that very well. It's a pretty troublesome situation. It's difficult to be working on security in DeFi today, certainly in crypto broadly. So let's talk a little bit, take some practical examples about the current state of smart contract security. We mentioned already how if you slip up even once in this industry, you will fall all the way down. Here's an example of that. We work with a project called ArmorFi. They put up what became ultimately a $1.5 million bounty, which we paid out in order to surface criticals to them, anything that could compromise the code. They were very understanding of this approach because their CTO, Robert Forster, was himself a bug hunter and had done a lot of interesting work in that field. Now, what he didn't know is that the team had made a very minor mistake in the logic of their claim contract. Consequently, if one person were to call this claim, they would claim exponentially more money than anticipated. ArmorFi is an insurance protocol, so you're going to claim the money when there has been damage caused to you. Now, effectively, if this command had been executed by the attacker in this way, they would steal all the money that was locked up in that contract. I believe today that's about $30 to $40 million. Very small mistake, but it would result in a 100% KO, a $40 million theft. And of course, the end of the project, like you can't recover from that. You're done. So like this threat is real. Now, in this particular case, we were able to protect them by surfacing this early, proving the point. The only way to protect yourself against this kind of like long tail of vulnerabilities, like there's such a potential variety of vulnerabilities with such complexity that it's difficult to foresee what they could be. There's no checklist that you can go down and say, I have everything covered. Right? The only way to protect yourself against these kinds of game-breaking vulnerabilities when it comes to dealing with dApps and DeFi is ultimately to get as many eyes, as many skilled eyes on this code as you can. Only by putting it in front of as many people as possible will you be able to surface these vulnerabilities, effectively disclose them, and ultimately help fix them. Now, before I go farther, I want to talk about audits. So we often get the question when working with our partners, well, we got an audit, what do we need this for? And the reality is audits are fantastic, and we recommend all of our customers get audits. We have a variety of partners that we recommend. We say, hey, you need an audit, you should go and get them. In fact, we recommend you get two, each overlapping with each other to make sure you can do it. But the reality is that audits are not enough. They don't pretend to be enough. Auditors don't say they're enough. Audits are merely one thing that you absolutely need to be doing. And audits aren't enough because it's very challenging to be an auditor. Yes, you have to be highly skilled. You have to know a variety of attack vectors. You have to know the EVM inside and out. And then a customer comes and they give you a job. They say, hey, I want you to find everything wrong with my code and then sign off on it. Now, if you're an auditor, you've been paid X dollars over Y number of weeks, and you're going to do your absolute best to both understand the code and then think as an adversary and break it down. But the reality is you're never really given enough time, right? There could be the attacker who thinks for weeks or for months, looking at creative solutions to crack this. There's going to be the attacker that leverages completely new attack vectors that weren't originally foreseeable to come and attack your project. This is how so many auditing firms like Certic, which does formal verification on a variety of projects, a number of their projects were hacked. ArmorFi 2 had their code audited by Heichi, but they also had this serious vulnerability. The reality is the space evolves so fast that you can't count on an audit to secure you, and you can't count on it to be sufficient for your security needs. Their sign-off, you definitely need their support because they're going to be better than you at looking through this, and they're going to look at this in a completely different way. But you need to do more. The audit is merely the first step in the security process, not the last. And it shouldn't even be one audit, it should be multiple. So I wanted to address that before people start telling me that bug bounties and audits do the same thing. They're not true at all. You'll find lots of vulnerabilities with every audit that you do, but bug bounties serve a fundamentally different purpose, which is like after the fact, once your infrastructure is as hardened as you think it can be. Once your code base is as secure as you think it can be, this is when you want to launch the bug bounty to incentivize, to create an open challenge to anyone to break what you've built. And if they can do that, then it's certainly worth the prize. Okay. Wanted to clarify that. Want my auditing friends to still love me. Very important. Let's talk about fair market value. Another objection. So when I talk to people in the security community or we talk to projects, this all makes sense to them. Like we don't have to explain to people that the incentive for a black hat to attack your contracts is off the charts. 40, 50 million, 100 million. They already understand that. What people often balk at, and we've had people balk at it both at potential customers that we work with, and we've had white hats themselves. They look at this in disbelief. They're like, how could you say there's bug bounties aren't worth that much? That's crazy. We get that complaint. Complaint is not the right word. We get that objection. Our response to that is, or to be specific, we get the objection that that's way overpriced for a bug bounty. A bug bounty for $1.5 million, that's crazy. How could any bug deserve that kind of payoff? This is the bug bounty that we paid out to Alexander Schleindwein for the ArmorFi critical. And our response to that is, look, the world you live in where a critical vulnerability on a web application is worth $10,000, that is a different world. DeFi is a different world. The reality is there is a market for vulnerabilities. And we see that because anytime a hacker finds a vulnerability, he has two options. He can responsibly disclose it with or without a bug bounty program. Everybody knows that disclosure is a possibility. And certainly many projects are very front and center with that. Or he can attempt to exploit it and make off with the money. The reality is, over the last year, an incredible number of hackers have opted for exploitation. Someone comes and tells me, well, what's the fair market value of a critical vulnerability? The hackers themselves are telling you what it's worth. They're telling you that these vulnerabilities are so valuable that they're willing to go to jail, that they're willing to have someone come after them, that they're willing to take on a huge risk of bad things happening to them because they are simply so valuable that they cannot disclose them and get paid 10K. Let's talk examples. Acropolis lost $2 million after a black hat found a vulnerability in one of their vaults. They drained the funds. Could have been disclosed. They didn't. UnChained a few weeks ago on the V1 WiDi vaults, $11 million stolen. Hacker only got away with $1.5 million. The remaining portion, which is about $10.5 million, was paid in fees, primarily to Curve. Harvest Finance, another attack, $30 million. They had the option to disclose, they chose not to. Black hats are telling us how much they think these vulnerabilities are worth. And remember, we don't know who these people are. None of them have been caught. We call them a black hat only because they exploited it. We should not be thinking of these people as, specifically people who are malicious enough to get you, even though they absolutely engaged in criminal activities. What we should be thinking about it as people who chose to make money this way because they thought it was better. And that's kind of understandable. Let's take the Harvest Finance. So Harvest Finance is one of our flagship clients on Immunify. We've helped them with a number of vulnerabilities. We've been very happy to work with them. They're a very effective team. They run a $50,000 critical bug bounty. Now that was compared to the $30 million that they lost. Now, suppose the next event comes, a hacker discovers a serious vulnerability. Of course, we want them to disclose it to us. We help as many of our bug hunters to look at their code base and support them in these discussions as possible. But the reality is, if a hacker finds a vulnerability and he can make $10 million or he can make 50K, it is challenging. It is challenging to make the pitch that you really should disclose. We do it every time. We try our best, but the reality is there's 200 times more the value in theft. So whether we like it or not, the hackers are very clear about what they think the value of these vulnerabilities are, which is millions and tens of millions of dollars. And so our response to that as a company is well, we need to end these hacks. We need to save as many user funds as possible. How can we do that? Well, the simple answer is we can create massive incentives for the community of security people, that's all of us, to go in and protect these protocols. And we can do that very simply. We can connect the value of a bug bounty to the value of the funds at risk. If we do that, you're going to see massive incentives to protect these projects, which should be so large and so compelling that they should even sway the black hats themselves to go bleach their hats, as it were, and to responsibly disclose. Let's take an example of this. Perpetual Protocol, a very interesting Australian project. We've worked closely with Nick on a number of vulnerabilities. We've been very happy. They're a very professional team. Now they have pegged 10% of anything in their clearinghouse contract as a reward for bug bounties that would result in loss of user funds. This means of all the money moving through perpetual contracts, 10% of the money that is about to exit the system is always there to incentivize people to responsibly disclose it. And that's a pretty compelling offer, we feel. The reason we feel that is because when you responsibly disclose and you get that 10%, you don't just get that, you also get $1 million. You get a fantastic reputation, of course, as a white hat in the space, and you can go and spend that money today. Whereas any black hat understands that even if you take 100%, even if you steal that amount of money, it comes with tons of risk of horrible things happening to you. Nobody likes it. And you have to discount that value pretty heavily. And so after you go through all the very heavy fees and cleaning, which could be 10, 20, 30%, plus the risk that you have to take, your end value, your expected value on a hack is probably about close to the 10% that you could have gotten with a scaling bug bounty. So this is why we think that, by adopting scaling bug bounties at a mere 10%, we're not sure what the right answer is, probably between 5 and 25, but starting with 10%, we think this is enough to just get a lot more vulnerabilities disclosed in the ecosystem, which is going to mature the security community in DeFi much faster than it otherwise would be. And ultimately, it's that scaling factor, that's what determines the fair market value. And when the hackers start disclosing instead of hacking, that's when we're going to know that we've about landed on the right number. So again, pulling it back to the ArmorFi example, they posted what was originally a $700K US dollar critical bug bounty in Armor. Within 24 hours, one of our bug hunters, the exceptionally talented Alexander Schlenwein, combed through the code and cracked it. This allowed us to preemptively protect ArmorFi, which was a long night, a long and stressful night. Alexander got paid what eventually became $1.5 million because the community was so happy with the way ArmorFi responded to the situation and its disclosure that the value of their token increased dramatically. This is what we feel is going to be the rule. Taking bug bounties seriously is going to be something that investors and the market increasingly reward because it shows that you take security seriously. And gentlemen like Alexander Schlindwein are effectively the heroes of decentralized finance. They literally save user funds. This attack in particular would have absolutely destroyed confidence in Armor. So Robert's decision to preemptively to put a bug bounty on ArmorFi as soon as possible it was like a tremendously high ROI decision on his part that has served the project enormously well. Since then, ArmorFi has continued to grow in success, and they have Alexander to thank for that. Now, the alternative to do that, say to launch without sufficient code review, and certainly to launch without a bug bounty, no even incentive for someone to help you if they find something wrong, that's risking sudden death. Lots of projects do, lots of projects have died, even more are going to. Any savvy business person is going to say that that doesn't really make any sense, and they're going to stop that. So this is a big part of why we think this is going to become the norm. These kinds of bug bounties are just going to make sense. And when we see this becoming the norm, I am seeing dozens, hundreds of projects having multi-million-dollar bounties, having even bounties in the tens of millions of dollars. Could be possible this year. I would stay tuned to immunify.com, see what we can do on that. But this is certainly where we think things are going. And we do expect these bounties to be floating. So a big advantage is that the projects can pay in the tokens themselves, which gives them more flexibilities. And this will further drive up the values. Okay, let's talk about bug bounties. Just to recap everything for us all. So these security needs are a matter of incentives. They're not a matter of something that we need to speculate on and be like, oh, is this going to happen? Oh, this could be like this and such and such. No, this is just the incentives today. We have an inefficient market. The response to that is hacks and theft. The projects themselves are going to respond to that punishment from the market by increasing their bug bounties to compensate people who disclose those vulnerabilities. That's already happening. We have a number of massive bounties in our own pipeline that we're launching at immunify.com, and it's going to accelerate. It's not going away. Now, these payouts are going to be absolutely life-changing. We've just did the first one, so we paid out $1.5 million to Alexander. Earlier this week, we paid out a $300,000 bug bounty to the DDoP team for their work on Primitive. We expect this to be the norm. We've paid out, multiple 5- and 6-figure bounties now in other contexts. This is just going to be a part of the new career path that decentralized finance brings with it. Security talent is going to be extremely heavily rewarded in this new financial ecosystem. What are we doing at Immunify? Well, we're doing basically everything we can to support bug hunters. So of course we have our own central community at Immunify, and we spend all of our time getting more customers, setting the standard for what we think constitutes good behavior. That means high bounties. That means highly respectful communications. That means clear expectations in dealing. And then of course we champion our bug hunters. So we help triage the results for our projects and handle the communications directly, always making sure that we represent the interests of the security community first and foremost, right? Our job is to support the bug hunters as much as we can via our influence over our clients, via the community and setting expectations about how these things should be valued and how bug hunters should be treated, and via tools and technology that we're increasingly creating to support the finding of vulnerabilities in the space. If you'd like to get started with this, you can always go to immunify.com. We have hundreds of aggregated bug bounties there, about $8 million in prizes available now. A number are going to increase very soon. And then we've also prepared a page, immunify.com/learn, for those of you who want to learn how to hack these smart contracts as well. That's where I would start, and I would start doing capture the flag exercises or capture the other exercises as quickly as you can in order to get up to speed. I think we're at about the end. So here's my Twitter handle, @AdamUnify for the team. You could always get in touch with us directly at team@adamunify.com. And questions. Not sure we have enough time, but if anybody has any questions, now would be good.
Hey, Michelle. Yeah, so we are having two questions, I guess. So someone asked, I'm able to connect Peter's talk with Michelle's. So Peter talked about the attacks that happened, and you talk about the bug bounties. So he's trying to connect both of them together. So it's a good thing. People are engaging with all the speakers and learning new things, and they want to surely come into bug bounty as well. Someone asked how we can start with bug bounties.
Sure, good question. Well, the best way to start with bug bounties is go to immunify.com and take a look at what's available. If you don't already have the skills, immunify.com/learn is a good place to start. We have resources from across the space for learning how to work on the EVM in this way. And if you can find vulnerabilities in contracts and bring them to us, we'll take care of the rest and get you paid. That's the simplest way. And of course, you mentioned Peter, so I would recommend to anyone who wants to get involved in this industry to get on BlockThreat, sign up for his email list. He has the best information on hacks that are happening so that you can learn as soon as the hacks happen, what were the methods used, go through the postmortem, understand the method in case you yourself can find other projects with the same vulnerability. Extremely valuable resource.
Right. So everyone, you got your answer. You can follow Peter's blog about the blog thread, and then come to Immunify, submit your bugs, and get paid. Yep, that's an awesome life that you can settle with. So yep, I think that's all for our session. Let's just wait for 1 or 2 more minutes to see if anyone's having any other question.
I think we answered them all. I'm glad we were so thorough.
Right. So yes, I think there are no more questions. So we can wrap this session, and I'm gonna wrap our conference as well. So thank you so much, Michelle, for taking out the valuable time for us and speaking about something very interesting, that is bug bounty, including in our conference. That has added much worth to our conference. Thank you so much.
My pleasure. Have a great night,
So,
everyone.
bye. See ya. So hey everyone, so you are seeing me back and my tired eyes. So we covered a variety of talks from industry speakers, right? Let me share my screen for a second. Let me check what we have covered. All right. So we started with 3:30 p.m. An IST. We started our journey of UnChained, and then we came with a bunch of speakers from all around the world, sharing their wonderful piece of information from malicious behavior in cryptocurrencies to secret rollups to how we can set up and secure our blockchain. Then from Peter, we learned about the state of blockchain security. Josh told us about how we can secure our wallets and why is it important, why the basics of wallets and wallet security is very important for us to understand. Then we got a workshop from Joran and Smita talking about the scribble and how we can write smart contract properties with that. And then we got our speaker Deepak Nuli. He talked about security consultations in a Web3 world. And then we had Nicholas. He talked about how we can shrink and secure our smart contracts. A lot of new topics were discovered, like Hop and KVM framework, right? So definitely we're gonna be checking them out. And then obviously we got Michelle Amador talked about how a Depi can make bug bounties explode in size. So that was a wraparound for our day one. So according to our schedule, at this moment, we should be like concluding our conference, right? Ending our Unchained. But I think we can go a little bit more. What say? So, yep, we are not done yet. We'll be talking more on 27th of February. So that is if in IST, that is already started. So we're gonna meet again at 3:30 p.m. and we will be having a techie security panel. And we will be having a panelist from the DeFi security area and industry. They will be Wasa, Web Seni, or aka Vasa. There will be Google Alex and other bunch of panelists. That's our little secret. And any speaker if want to join, they are welcome. And we'll be having a lot of discussion over it and having a lot of fun. So yep, that's it. And I'm wrapping around the first day of our Unchained Blockchain Security Conference, and I want to thank each and every speaker for taking out the available time for us, sharing their wonderful piece of information. Their workshop, we got to learn a lot, and we have learned a lot from them. And definitely, our audience have got a lot many things to discover, and they will be sharing much more insights with their speakers. So that's it for today and for our day one. And I hope to see you all back today, according to IST. That is 27th of February, and you all watch us again in the DeFi security panel. So this is me, Tejas Rastogi, and I'm signing out for the day one, and we'll see you on the other side of the day. Bye bye. Have a nice day.